Everything happens for a reason. Whatever it is, good or bad, maybe it's not according to our own plans, but it happens for a reason. And all that happens because God wants you to become the best version of you.
Hi there, my name is Mihai and I want to welcome you to my course. So, you want to learn Python? That's great, because Python is a great programming language used across many IT areas, from web development to network or test automation. But how can you decide on which course to choose to start your programming adventure? Well, for example, I tried a few books on this topic, but I got bored pretty quick and gave up. Then I have enrolled in some online courses. Although they weren't as boring as the books, I still felt I'm not learning the language itself. Instead, I felt bombarded with tons of theoretical concepts and definitions, which are not very attractive for a beginner. Finally, I decided to take each of the major Python topics and practice them by simply writing code, testing, failing, testing again, and in the end succeeding. This method was way more efficient than reading about Python or memorizing definitions or things like that. That's why I decided I should provide you with the same method, and I have created this course, which is entirely a hands-on course. I will guide you through the Python language, starting from handling variables, strings, or lists, up to advanced topics like iterators, generators, and even database operations. I guarantee that with this course you will understand, test, and remember Python concepts way better than you would using the old boring methods with tons of slides and theory. So, let's get to work. Okay, so why Python? Why would you choose Python over other languages like C or Perl or Ruby or JavaScript for your networking needs? Well, first of all, Python comes with great documentation and a wide community for support. In fact, doing a simple Google search on Python will return a ton of results to answer your questions. Python has a very clean syntax, and this will be a great advantage for you as a beginner. Code readability is another key strength of Python. This means that if you write a piece of code today, and 6 months later you return to that piece of code, it will be very easy for you to realize what you've done there. Python is open source, it's free, and this is true for both Python 2 and Python 3. Code portability is another great feature of Python. Applications and scripts written in Python are portable across Windows, Unix, and Mac OS. Python is an interactive language and a dynamic language. It has a built-in interpreter and requires no pre-compiling to run code. Modularity is another key strength of Python. You can group code into modules and packages, and further import those modules into your applications. So, what is Python used for? Python is a great language for web development. Python is also a great language for network applications, and we will see that across this course. Python is a great scripting language and a very good tool for software testing. Python also comes with a ton of libraries and modules for graphical user interface development and scientific applications. So, I think this sounds pretty good, right? Let's get started. Okay guys, so let's have a look at the necessary hardware and software for this course. First of all, I want to mention that I'm using a laptop with a 2.3 GHz processor and 8 GB of RAM. But you shouldn't worry, a 2 GHz CPU and 4 GB of RAM should be enough to run the software we need for this course. As for the software setup, I am using Windows 8.1 as my host operating system, on top of which I have GNS3 and VirtualBox installed. Now, as you probably know, GNS3 is a free software and it is used for network emulation. We are going to need GNS3 in the second part of our course. Another thing I should mention is that you have to provide your own copy of Cisco's router operating system, Cisco IOS, in order to load it into GNS3 and emulate network devices. We'll talk more about setting up GNS3 in a dedicated section. Now moving on, VirtualBox is also free to use, and I am using it because it has great integration with GNS3. We're going to see that later on. Inside VirtualBox, we are going to use Debian Linux 7. I think this version is called Wheezy or something like that, funny name anyway. Usually most Linux distributions come with Python and maybe MySQL pre-installed. Debian 7 has both of them available. Also, for the application building part of the course, I strongly recommend using a more advanced text editor because we will work with a lot of code and the Linux default editor does not have a lot of features to help you deal more easily with many lines of code. So I am using Komodo Edit. It is free. It has a lot of cool features like code completion and syntax highlighting, thus making the code easier to read, write, and maintain. But you can use any other software if you don't like Komodo Edit. In the additional section of this lecture, I have included a download link where you can find the installers for the exact same versions of GNS3 and VirtualBox I use, so we will have synchronized versions along the way. I think this would be really helpful. Now you can do this in two ways, the hard way or the easy way. If you feel like a hero and have a lot of time for installing and maybe troubleshooting software and Python additional modules, you can download and install all of them into a virtual machine of your choice. I added a document with links to all of these software resources. On the other hand, if you want to quickly configure your work environment and get down to business with Python, I would really recommend the easy way. This means you should follow the download link attached to this lecture. There you will find three folders. The first folder is called VirtualBox. Download the installation kit from there and run it on your host operating system. The second folder contains the Debian Linux virtual machine zip archive, which is about 2.3 gigabytes. You should download it, unzip it, and run it in VirtualBox. This is where 99% of our work will take place. Later on, we will modify a few settings into VirtualBox to integrate it with the network in GNS3. Thirdly, you will find the GNS3 folder having the GNS3 installer, and also other resources we will use to build our network applications. But we are going to use GNS3 later in the course, so we'll talk more about it at that point. As a side note, if you run into an error while starting the virtual machine in VirtualBox, this is due to some differences between various hardware configurations. If this happens, you should modify the following setting. In the VirtualBox main screen, select the Debian 7 virtual machine, then go to Settings in the upper part of the screen, go to the System tab, and then check the Enable PAE and X checkbox. Next, start the virtual machine again, and this time it should be booted without any issues. So, having that said, I hope you can easily build your work environment and start handling Python code in the next lecture. Hi guys, so this is my Windows desktop. I am using Windows 8.1 for this course as my host operating system. Of course, you can use any operating system you like. I have also installed VirtualBox and created a shortcut on my desktop. VirtualBox is already running, as you can see. This is the home screen. I have already imported the Debian 7 virtual machine, which you can download from my Google Drive. So let's get on to Debian 7. This is the Linux logon screen. For this course, you will use the Debian user and the Debian password for this user. So Debian and enter. It may take a while to load all the shortcuts on the desktop and all the menus because I have provided only a gigabyte of RAM to this virtual machine. Okay, so here we have the desktop and the shortcuts. Okay. First of all, you can see two menus in the upper left corner of the screen. This is the application menu. Here you can find almost all applications which are installed on this Linux distribution. This is the Places menu. This is somewhat equivalent to the My Computer menu in Windows. Moving to the desktop shortcuts, here is the My Computer shortcut. This is the home folder for the Debian user, so somewhat like the My Documents folder in Windows, I think. This is the trash, the recycle bin, and this is the fun part. Here we have two types of terminals. This is the regular terminal, in which regular users do their work without having any super user privileges. And this is the root terminal, which has root privileges in order to run high-level commands on the Linux system. We will mainly use the root terminal across this course because it will save us some time when we want to run any command which requires super user credentials. Okay, so double click on the root terminal. The root password is root, R-O-O-T. Okay, it should open up pretty soon. Okay, this is it. This is the Linux shell, also called the Linux terminal. It has already detected that we are logged on as super user. The default folder in which we are located from the very beginning is the home folder of the Debian user. So if we will list this folder using the ls command, we will see a bunch of other folders. In Linux, these are also called directories. So I think you can use the terms interchangeable. We have the desktop directory, the downloads directory. These are Linux defaults. This is the Python modules directory, which I have created. So let's do ls on that. ls python. Okay. Here we can find a lot of other directories. These are all the Python modules which I have already downloaded and installed them for you in this Linux machine. So you shouldn't worry for any of these folders right here because they are left here mainly for backup reasons. I have also created another folder. It is named working there. So let's do an ls on that. Well, you can see it's currently empty because we haven't done any work until now. But rest assured that this directory will fill up pretty soon. Okay, so moving on to the Python interpreter shell. Let's see how we can access it. It's simple, just by typing Python and enter. This redirects us to another prompt, to another shell. This is Python's own shell. First of all, you can see some basic info about this version of Python. We are currently using Python 2.7.3. It has detected that we are running this version of Python on a Linux machine. And finally, these are some basic commands to help you get started with the Python shell. Okay, so what is this shell good for? Well, first of all, you can look at this Python interpreter shell as a live session of Python. This means that you can quickly run some pieces of code into this shell to save you some time on obtaining some very quick results on I don't know, some operations or some formulas or some functions you are planning to use into your programs. Okay, let's start with some basics. You can use the Python shell as a simple calculator. So let's do 1 plus 1 equals 2. Okay, subtraction, 1 minus 1, 0. Okay, so it runs pretty smooth. You can do multiplication, so 8 times 7, 56. Okay, runs pretty good. What else? You can do string concatenation. This means that you can take two or more strings and unify them into a single string. So let's assume that you have the hello string. By the way, we will talk about strings later on in this course, but for now you should know that in Python strings are enclosed between double quotes or single quotes, doesn't matter. Okay, so this is the hello string inside double quotes, and this is the same hello string between simple quotes or single quotes. Okay, so same thing. What if we want to unify this string with another string, let's say hello and Python, two different strings. Okay, so what if we want to print to the screen hello Python? Well, we will use the plus sign as we do with numbers. So let's test it. Okay, hello Python. Furthermore, you can create classes, you can define functions, you can use more advanced mathematical formulas or any other kinds of valid Python statements to give you instant results on your actions, and furthermore, use those results further into your programs. Okay, so this will be pretty much it for this quick introduction on the Python interpreter shell. This has been a broad overview of the shell. Don't worry, we will use this interpreter shell across this course many times. So you will see a lot of examples of Python code run into the Python interpreter shell. Alright, so we've looked at the Python interpreter shell. That was one way of running Python code. Another way of running Python code is by using a Python file, also called a Python script. This is nothing more than just a text file with a .py extension. Do not forget the .py extension, it is very important. Okay, so let's create such a file. Let's see where we are currently located. Okay, so we are in the home Debian folder. Let's do an ls on that. So we can see the working dir directory. Let's go to this directory, so cd working dir. This is the directory in which we are going to do most of our work from now on. Okay, so first of all, let's create the file. We are going to use the Linux touch command, so touch. You can name the file whatever you like. We are going to name it file1, and do not forget the extension .py. Okay, so let's do an ls on that. So the file1.py file is created into the working dir directory. Now, how can we edit it? How can we insert Python code into it? Well, we are going to use the Linux built-in Vim text editor. So vim file1.py and enter. We are currently located into the file1.py file. To insert some text into this file, you can press the I key on your keyboard, and as soon as you press that key, the insert statement will appear in the lower left corner of the screen. This means that you can now enter any type of text you like. For starters, we are going to use a basic Python command, and that is the print command. This command does nothing more than just print some text that we input onto the screen. So let's use print and let's type a string, hello Python, for example. Okay, so remember, Python strings are enclosed between double quotes or between simple quotes, doesn't matter, just don't forget them. Okay, so I think this is the most basic Python script you will ever write. Print hello Python. Nothing more. Now let's save the file. First we should hit the escape key and then use the colon key, double for write and Q for quit. So escape, colon, W and Q. And now enter. Okay, the file is saved. We can check that our statement, our print hello Python statement, was saved into the file by using the cat Linux command. So cat file.py. Okay, so the statement is there. It should be alright. Now, how can we run this Python script? Well, it is very simple. Just type Python and the name of the file, file1.py, and hit enter. As soon as you hit enter, hello Python is printed to the screen without the print or without the double quotes or I don't know, single quotes or whatever you used. Just hello Python is printed to the screen. So, as I said, this is a very basic Python script. You just have to remember the idea of creating a file, giving it the .py extension, then saving the file, and then running the file using the Python command and the name of the file. So I think that's about it. These are the basics of Python scripts, Python files. We are going to use a lot of Python files across our course, so don't worry. you will have a lot of time to practice on this Python script technique. So let's get on to the next lecture. We've seen the two ways in which we can run Python code, and these are the Python interpreter shell and Python scripts. Now, let's see how can we insert some data into our programs and how can we deal with our Python applications in a more interactive way. First, let's return to our file and run it one more time. So we are currently in the working directory. Let's do an ls. The file is still there. Let's run the file one more time. So Python file1.py. Okay, it still returns hello Python as expected. Now, what if you want to run the same file multiple times and print different strings each time you run it? So you want to keep the print functionality in the file and only change the actual output to the screen. Well, you can do that by modifying, saving, and running the file each time, but really that would be very time consuming. One way to accomplish this task and save time is to use the Python sys module. We will talk about modules and importing them later on in the course, but for now, you should keep in mind that a module is just a Python file having some code within it and some functionality. The sys module is mainly used to access interpreter variables like, for example, command arguments, and it is a Python built-in module, so you don't have to worry about downloading and installing it. It is already there for you. So, how can we access a Python module from within our file? Well, simple enough. Let's go into the file using the same Vim editor, so vim file1.py, hit I for insert. Okay, so now we are in the insert mode. Okay, we should use the import statement followed by the module name. So let's go to the file and add import and the name of the file, and that is sys, at the beginning of the file. By adding this statement into our file, we will tell Python to run the code inside the module before running whatever we have written after it, in order to have all the module's functions and other specific data available further on in our program. So each time we want to access one of the module's functions, we will write the module's name before the function. So if we want to use function x, let's say, in the sys module, into our own script, then we will use sys.x to access that specific function. Okay, now returning to our hello Python script, we will use a built-in function from within the sys module. The function is called argv, and its job is to access and return the arguments we are passing in a command. So instead of printing hello Python explicitly, let's print the argument we are passing to the Python command when running the script. There's one more trick here. If we will print just sys.argv, Python will return a list of all the command arguments that we pass to the Python command. Okay, let's see that. So let's delete that. And instead of hello Python, let's print just sys.argv. Okay, let's save it and run it. Okay, so we see here a list of arguments which were passed into the Python command. In our case, it is just file1.py, so the file name. What if we run the same command and we add another argument? So let's say the old hello Python. Okay, now we see a list which is composed of two elements. First is the file name, and the second element is the string we entered and we wanted to be printed to the screen. Okay, so Python will return a list of all the command arguments that we passed to the Python command. The first is the file name, but really we are interested in printing just the second argument. This is the string we want to be printed out on our screen. So let's get back to the file and specify which argument we want to receive. As a side note, in Python, when counting the elements in a sequence, the counting usually starts from 0, not 1. So in the list of arguments we got back from the print sys.argv, Although the hello Python string was the second element, its position from Python's point of view, also called an index, is 1, because 0 would be the first argument, the file name. I hope this makes sense. If it doesn't, don't worry, we will work with indexes a lot further in the course. Now, back to our file. Let's tell Python that we want just the second argument to be returned to the screen. We want to do this by adding the index we want in between square brackets after sys.argv. So let's go back, insert. So after sys.argv, we want the second element to be printed out on the screen. So this is the one index. Okay, that's it. Let's save it and run it one more time. Okay, so we have hello Python. Let's try this with other strings. So let's see hello Java. Okay, let's see hello Perl. Okay, and further on. Perfect. So remember, use sys.argv and the correct index whenever you want to pass arguments to a Python script, and whenever you want to save time to print or, I don't know, access other functionality of a script in an interactive way. Another way of inserting some input into a program is to use the row input function. This function prompts the user for input and uses that input further into the user's Python program. This could be very useful for creating interactive menus like please enter something, a username or a password, or any other string, or choose an option from the following list kind of menu. Now, let's return to our file1.py file and prompt the user to enter the string he wants to be printed out on the screen. So we are currently in the working directory. Let's do an ls, the file's still there. Let's do a cat on file1.py. We still have the old sys.argv technique here. Okay, let's remove the sys module references from the previous lecture and use the row input function this time. So using vim, let's edit the file, I for insert. Now delete the import sys, and don't worry, the row input function is a Python built-in function, so you don't have to import any module to use it. Okay, so now we just have the print. Okay, so instead of printing sys.argv and passing the desired string as a command argument, we are going to ask the user to enter whatever he wants. So print row input, Now open parentheses, close parentheses, and you should type here a description, which is actually a string stating what the user should input after the colon. So please enter the string you want to be printed out. Colon, let's leave a space, close the double quotes, and that's about it. The description, being a string, do not forget to enclose it by double or single quotes. For visual purposes, you should also leave a blank space after the colon, so when the user inputs some data, it will be clearly separated from the input description. Okay, so that's it. Now let's save the file and run it. Escape, colon, W and Q. Okay, let's run the file, Python, file1.py. Okay, you see now that the program asks you to enter whatever you want to be displayed on the screen, so let's try a couple of things. Okay, so hello Python. Nice. Let's run the file again. This time, let's go with hello Java. Okay, this time, let's go to Python in networking. Okay, nice. It works like a charm. So, keep in mind that you are able to capture user input, display this input, or even store it inside a variable and use it across your script. We will talk more about variables pretty soon, so don't worry if you know nothing about them at this point. Now, it's time to see two very helpful commands to use in the Python interpreter shell. Okay, let's say that you want to use a Python module, or you just hear about one and want to find out how it works and what functions are available to you inside that module. In that case, Python gives you two helpful commands to quickly find out more information about a module's functionality and contents. Let's see the commands in action by using the Python interpreter shell. So, okay, Python, enter. We are now in the Python interpreter shell. And let's say that we heard about the sys module and we want to find out if it can actually help us to achieve our goal. As a side note, keep in mind that you should already have the Python module installed if it's not a Python built-in module like our sys example. Second of all, you should first import that module into the Python interpreter so Python can access its information and display it to you. Okay, so let's do an import sys. That's it. Okay, the first command is help. So let's do a help on sys and see the results. Help, open parentheses, close parentheses, and sys. Sys. Okay, the command returns you the module name, the module source. In our case, this is a built-in module. The location in which you can find detailed documentation about the module, and a short description of the module's functionality. To quit this screen, just type Q and you're back in the Python interpreter. Okay, the second command is dir. This command shows you which commands or functions are part of the specified module. So, now let's use dir on our sys module and see its available function or functions. Back to the Python interpreter, let's type dir of sys, enter. We can see here a list of available functions in this module. Here is the argv function we used earlier to print the arguments passed to a command. Other functions are also available, as you can see. We are not going to discuss them, just remember the argv function in this module. Okay, so keep in mind that these two commands, help and dir, are there to help you get more info about any Python module. So use them whenever you feel uncertain about a module. What is a variable? How can we define a variable and what is it good for in Python? A variable is nothing more than just a reserved location in your computer's memory in which you can store information, values to be more precise. You can store different types of data into a variable. You can store a string, a number, or any other data type. Now, unlike other programming languages, in Python you don't have to explicitly declare a variable. Instead, the declaration is done automatically when you assign a value to that variable, no matter what type of data you decide to assign to that memory location. Furthermore, you can access the value stored in that variable and modify it. Now, let's think of how you should name a variable in Python. Well, there are several rules to consider and follow for a clean and compliant code. First, a variable name should always start with a letter, usually lowercase, and never start with a number or any other symbol. There is one exception to this rule. Some names start with underscore or double underscore. In Python. But these are Python-specific structures, so let's leave them to Python. The variable name may contain lowercase or uppercase letters, numbers, and the underscore sign, but, as I said, not in the first letter. Also, do not include spaces or other characters inside variable names, no dollar signs, no commas, no parentheses. And remember, Python names are case sensitive, so a variable named my underscore var is not the same variable as my underscore var with an uppercase V. Another thing about variable names is that you should keep a reasonable name length, so it is easier for you to remember and refer to inside your code. The last thing I should mention on this topic is that there are some Python reserved names which you cannot use as a variable name. I have included a list of those Python keywords. You should read it anytime you're in doubt. Now, let's see how can we assign a value to a variable. Well, the rule is to use the equal sign. Let's go into the Python interpreter shell. Okay, the equal sign should be regarded as an assignment operator rather than the usual equal sign used in math. In the left side of the equal sign, you type the variable name. So let's type my var. And in the right side, you type the value you want to assign to that variable. So equals and the value of 10. It doesn't matter if you leave a space between each side and the equal sign. I would advise you to leave a space on each side though for better readability. Okay, so let's see my var, it has the value 10. Okay. You are also able to do multiple assignments, so you can assign a value to multiple variables in the same time. The syntax for that would be, let's use variables a, b, and c. A equals b equals c equals 20. Okay, so now let's see each variable. A is 20, b is 20, and c is 20. Okay, or you can assign a different value for each variable within the same line of code, like this. Let's use the same a, b, and c variables. A, b, and c separated by a comma equals 1, 2, and 3. The values should be also separated by commas. Okay, now let's check A is 1, B is 2, and C is 3. Okay, I think that's really cool and may come in handy someday. Now, let's have a brief look at how Python does variable assignment. For this, we are going to use the id built-in function in Python, which gives us the identity, the location ID of a variable in memory. Okay, so let's assign the value 10 to variable a equals 10. Now let's use id to see what is the address or identity of the value 10 in memory. So id of 10, it gives you a big number. Don't worry about it. You don't have to memorize that number. This is just the location of 10 in memory, in the computer's memory. Okay. Let's do the same thing on a. So id of a. You can see that the value is the same. That's because a is pointing to the location in memory in which 10 is stored, because we assigned it that way. Now, let's create variable b, which points to variable a. So b equals a. And now let's use id of b to see its location. So id of b. Okay, surprise, surprise, we got the same value as above. This is because b is also pointing to the location in memory where 10 is stored. Think of this like putting two labels on the same recipient. The content of the recipient is the same, but it can be referred in two ways depending on which label you read. Okay, now let's change the value of b to 20. So b equals 20. And check its ID again. So ID of b, b of b. Okay, as you can see, b's ID is now different than before, because b is now pointing to the location in memory in which 20, the value 20, is stored. But the ID of a is still the same, although we did b equals to a above. Okay, so let's see id of a. Oh, sorry, id of a. Okay, so a has the same location in memory, the same address, because it is still pointing to the 10 value. Okay, since we are interested in the practical use of Python in our networks, I will not get into any more details regarding memory assignment or other deep concepts. Instead, I would prefer to talk about which data types we will encounter in Python in the next lecture. Following up on the previous lecture, let's see what types of data can be stored in memory and used by Python applications. The Python programming language defines many types of data for many types of operations. We will have a look at the most widely used data types starting in this lecture. As an overview, let's enumerate the most famous and useful Python data types. So, we have strings, numbers, Booleans, lists, tuples, dictionaries, and sets. We also have the none type, none with a capital N. None is used to represent the absence of a value. You should see it as being equivalent to nothing or empty. All these data types are built in the Python language core, and you will see that they are very clearly defined and very easy to use. Okay, one way to classify data types is by whether the objects of a data type can be modified after creation or not. So, this leads to two kinds of data types. Mutable types, which can be modified after creation. Here we can mention lists, dictionaries, and sets. And immutable. Here we have strings, numbers, and tuples. Of course, other data types may be included in these categories, but we will stick with the most famous ones for now. So remember, if you have an object of an immutable type, you cannot change the content of that object in any way. You will just have to create another object with the content you want. To find out the type of data for an object, you can use the type command in the Python interpreter shell. So let's check this out. Let's go to the shell, Python. Okay. Now let's create var1 and assign it the value hello. var2, let's set this equal to 10. And var3, let's set this equal to 1.5. Okay, now let's check the type for each of these variables. So, we are using type, open parenthesis, close parenthesis, and the variable name, var1. Okay, we can see that the type is str, this means string. And this is correct because hello, being enclosed by double quotes, is a string. Let's do the same for var2. We now see that the type is int, and this means integer. And of course, 10 is an integer, so this is correct also. Let's do this for var3 now. We can see type float. The type float is associated with numbers which have a decimal point within them, so this is correct again. Now, let's also create var4 and set this equal to 10 enclosed by double quotes. And check its type. Type of var4. And we can see that it is a string. And this is correct because although 10 is an integer, we enclosed it by double quotes, so it became a string. Okay, so keep in mind that you have the type function available whenever you want to check the data type of something. Now, it's time to have a closer look on a data type we already talked about earlier in the course, strings. Okay, let's talk about strings. Let's define a string first. A string is a sequence of characters, meaning letters, numbers, and other characters like the $sign, or spaces, or punctuation marks, enclosed by single quotes, double quotes, or even triple quotes when spanning multiple lines. So, let's define a string and assign it to a variable. I am going to create a variable named myString and assign it the following value. So equals, this is my first string. Let's check the value for this variable. Okay. Now let's do the same thing using single quotes. So myString, this is my first string. Let's check the variable again, and we got the same result. This is correct. So you can use both double quotes and single quotes for defining a string. Now what do we need triple quotes for? Well, we need them when we want to enter a string on multiple lines. For example, a comment into our code. Let's see how can we do this. Let's assign the same text to the myString variable, this time with each word being on a separate line. So myString equals triple quotes, this enter is my first string. And don't forget to close the triple quotes. Let's check the value for this variable now. Okay, so we got something new here. What's with all the \n's between the words? Well, they are called new line characters, and they signal a new line being created at that particular point in the string. Okay, so how can we get rid of them? Don't worry, it's simple. We just have to add a \, wherever we want a new line to be inserted. So let's test this. myString equals triple quotes, this and the \ is \ my first string, and close the triple quotes. Now let's check this again. So myString, and we got rid of the \n's. This is what we wanted in the first place. Cool. Now let's talk about indexing, and this applies to other data types also. Python uses indexes to mark the position of an element within a sequence of elements. Strings are also sequences of elements, and those elements are the characters in the string. The first element of a sequence, when counting from left to right, has the index 0. Then the second element has the index 1, and so on. When counting backwards from right to left, the first index will be -1, so the last letter in a string will always have index -1. And the next letter from right to left will have index -2, and so on. Indexes are enclosed by square brackets whenever we want to access some letter of a string. So let's see this in practice. Let's create variable string1 and assign it the value Cisco router. Let's see string1. Okay. How can we extract the first character of this string? Well, by using an index, of course. And that would be index 0. So to access an element of string1 positioned at index 0, we should type the following. The name of the variable, so string1, then without any spaces, the index number in between square brackets, so string1 of 0. And this gives us C, which is correct because this is the first character in the string. Now let's find the third character of string1. What index should we use? Well, index 2, right? So let's test this. String1 of 2 gives us S, correct again. Now let's see the sixth element of the string. We will need string1 of 5, right? So indeed we got the space in between Cisco and router. Don't forget, spaces count as characters too. Now for the negative indexes. Let's access the last character in the string. We will use index -1. So string1 of -1 returns R, which is indeed the last character in the string. What about string of -4? Who would that be? Well, let's count. We have R -1, E -2, T -3, and U -4. So the letter U should have index -4. Let's check this. String1 of -4. Okay, indeed, we were right again. Great. One more thing on indexes. What if we enter an invalid index for our string? First, let's find the length of our string. So for this we will use a function which is called len. This counts how many characters are in the string and returns the number of characters to us. So let's use the len function. So len of string1. This is how you use it. You specify the variable name in between the parentheses. So len of string1 returns 12. So we have 12 characters in our string. Great. Now back to the first question. What happens if we enter an invalid index? Well, let's try it. String1 has 12 characters, so counting from left to right, the last character should have the index 11, right? Let's test it. So string1 of 11 is indeed R. So this is equivalent to string1 of -1. Okay. Now let's see what happens if we enter string1 of, let's say, 20. So string1 of 20. Well, we get an error. Let's celebrate. It is the first error that we see in this course. Now let's read the error text. It says index error. This is the type of the error. There are many types of errors in Python, and we will go through the most common ones later in the course. Now let's continue reading this error. It says string index out of range. So Python found out that we typed an invalid index in between the square brackets and told us that the index is indeed out of range because a 12-character string cannot have a letter in position 20, obviously. Now it's time to have a look at some string operations to help us work with this data type. Okay, we've talked about indexing and how we can determine the length of a sequence, in our case a string, using the len function. Now let's see other operations on strings. First, one more thing about indexes. You can find out the index of a character in a given string by using the index function. Just remember that this function returns only the first occurrence of that particular character. So let's create a variable a and assign it the string Cisco switch. So Cisco switch. Okay, you can see that the letter I appears 2 times in this string, 1 and 2. So let's find out the index of the first I in this string. A.index of I. So the name of the variable associated with the string, a dot, and then index and I in between parentheses and in between double quotes. Okay, this returns 1 as being the index of the first occurrence of I in the string, which is correct since it is the second letter in that string. Another thing is that you can easily find out how many times does a character appear in a string, or generally speaking, an element within a sequence, by using the count function. The syntax is similar to the index function. You just type the name of the variable, a, then a dot, and then count. Open and close parentheses, and the letter you want to count in between quotes. So, a.count of I returns 2. So we have I 2 times inside our string, which is correct as well. Another string method is the find method. This method simply searches for a sequence of characters inside the string, and if it finds a match, then it returns the index where that sequence begins. So let's see that. Let's do a.find, of, let's say, SCO. Okay, we have a match starting at index 2, which is correct, 0, 1, and S is at index 2. If Python does not find a match, then it will return -1. So let's search for string, let's say, XYZ inside A, and we see -1 return because we don't have XYZ within A, obviously. Okay, let's see, what else? We can turn a string to lowercase or uppercase by using the lower and upper methods. So, returning to our string, let's do a.lower. Now we can see our string in lowercase only. And also let's do a.upper. Now all letters are in uppercase. Okay, notice one thing here. Although we applied the lower and upper methods on this string, A is the same string. This is a great proof that strings are indeed immutable. You can also verify that a string starts or ends with a particular character. We have two methods for this. They are called starts with and ends with. Let's see them in action. So, a.starts with, and let's say capital C, returns true. That's because it is true. Then a.ends with, let's say age, also returns true on the same logic. On the other hand, let's try a.ends with, let's try q. This returns false because our string ends in age, not q. Three important methods which you should keep in mind because we will use them a lot are the strip, split, and join methods. Let's see them one by one. First, strip eliminates all white spaces from the start and from the end of a string. So let's say we have another string with 3 spaces before Cisco and after switch. So let's say B equals space, 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 Cisco switch, and space, space, space again. Okay. Now let's apply the strip method on it and see the results. So b.strip returns Cisco switch without the spaces at the beginning and at the end of the string. That's nice. Now consider that instead of the 3 spaces on each side, we had 3 dollar signs we want to remove. So from a string that looks like this, C equals 3 dollar signs, Cisco switch, and 3 dollar signs again. So this is C. From this string, we want to eliminate the leading and trailing dollar signs. In this case, we must specify the character we want to remove in the strip method. So c.strip, and let's input the dollar sign, returns a nice and clean string. Okay, great. But what if we want all spaces removed from the string, including those inside the string? Then we would use the replace method, like this. So let's return to b, which has spaces at the beginning, inside, and at the end of the string. You can use replace like this to get the string clean, b.replace, and let me type this. So this would be a space character. We have a comma, and the second argument would be an empty string. Okay, so you are replacing every space character in the string with actually nothing. So let's try it. Okay, great, it works. So great job again. Now let's look at the split method. As the name implies, this method splits a string into substrings. Furthermore, you can specify a delimiter for splitting. The result of this method is a list. We will learn more about lists in a few lectures. So let's see this method in action. Let's say we have the string D like this. Let's say Cisco via Nortel HP Juniper, and that's it. Okay, let's see D. Okay. The networking providers in this string are delimited by commas. What if we want to extract each provider from the string in a nice format? Well, in this case, the split method saves the day. Let's do a d.split, and in between parentheses, let's specify the delimiter we want to split by. So, in our case, the comma. Okay. Python returns a list made of each provider from the string. Now, each provider is an element of this list and can be further used into an application. You can split by any delimiter you have in a string and get a list of elements that were separated by that delimiter. Finally, we have the join method. Let's remember string A, Cisco switch. What if we want to insert a character in between every 2 characters of this string? So we want to change this string to something like C underscore I underscore S underscore and so on. Then we will have to use the join method in the following way. And this is a bit different than the syntax for the previous methods. First, you type the character you want to use as a separator, enclosed by double quotes, so this would be the underscore in our case. Then you type a dot, then join, and in between parentheses you can specify the variable which holds the string you want to refer to. So in our case it is A. This could be read like this. Use the underscore character or separator to join the elements of string A. Now let's see the result. The result is correct. We got just what we wanted. Next, we will have a look at some string operators and string formatting. Okay, what else can we do with strings? We can concatenate them. This means unify two or more strings into a single string. You can do this with the plus operator, like you would do when adding two numbers. So, x equal to Cisco, this is a string, and y, also a string, equals to 2691, a Cisco model name. So let's add them together. X plus y gives us Cisco 2691. Okay, nice. Another thing we can do is string repetition by using the multiplication operator. So x times 3 gives us Cisco 3 times. X times 10 gives us Cisco 10 times, and so on. Nice. You can also verify if a character is in a string or not using the in and not in operators. This applies when having huge strings, but for now we will stick with our X string, which is Cisco, and check if the character O is inside this string. So O in X gives us true, okay, because O is the last letter of Cisco. Now let's verify if B is in X. Of course it isn't, and it gives us false. Now let's also use the not in keyword. So B not in X. This gives us true because we negate the existence of letter B in Cisco, which is indeed true. Now what's the deal with string formatting? Let's say we have some kind of string template and we want to constantly modify only a few words. Something like this. I have it saved somewhere, okay. So this is the string. This is a part from a Cisco router output. Okay, we want to keep this string as a template and just change the model name, the number of slots, and the iOS version a number of times. So this would be something dynamic. For this, we will use the percent operator, followed by s for strings, the percent d for digits, digits, this means numbers, okay, and the percent f for floating point numbers. Okay, so let's return to our string. This is it. Let's say we want to constantly modify the Cisco model name, the number of slots, and the iOS version. We will use the format operators we talked about. So %s because 2600xm is a string. We may use %d for the number of slots, or we can also use %s because it is part of a string, so it is treated like a string. And let's do the same for the iOS version, so %s again. Next, we should specify the format operator, which is the %sign. This is used to associate every format operator within the string with the values we will enter inside parentheses. So, open parentheses and close parentheses. For the first %s, we will have the Cisco model name, so in between double quotes, 2600xm. For the second %s, we will have the number of slots, which is 2. And for the third %s, we will have the iOS version, which is 12.4. Okay, so that's about it. Let's test it. Now we see that Python replaced the format operators with the values inside the parentheses. So we have the Cisco model, the number of slots, and the iOS version replaced correctly. Okay, now we can do this a couple of times with different values. So let's replace the model name. Let's say 2691. Let's say we have 4 slots and the iOS version is 12.3. Okay, so the string was updated with the new values. Let's try this one more time with, I don't know, 7200, no slots, and iOS 12.1. Okay, so this works as a charm. Nice, and it is useful too. Now it's time to wrap up with strings by learning about string slices. String slices allow us to extract various parts of a string. The general syntax for a string slice is the following. First, we have the name of the variable pointing to that string. So let's say var1, followed by square brackets. In between the brackets, we have a colon. On the left side of the colon, we specify the index at which to start the slicing. Now the slice will be up to, but not including, the index specified on the right side of the column. So let's say we start at index 1, up to, but not including index 5. So in this case, characters with indexes 1, 2, 3, and 4 will be considered for this slice. Okay, now let's see some examples in order to clarify this. I have a string saved inside variable string1. Okay. This is an OSPF route from a routing table, and let's say we want to slice some substrings out of it. First, let's extract the IP address in this string, the first IP address, 10.110.8.9, and get a substring from this IP address. Okay, we will use the string slice first, the name of the variable as I said, then the square brackets and the colon inside the brackets. Now on the left side of the colon, we will specify the index at which to start the slice. If we start counting from left to right, we will see that the first character of the IP address is 1 and it is positioned at index 5. So this will be the start of our slice. Now, if we continue counting, we will see that 9, which is the last character of the IP address, it's located at index 14. So in order to include 9 in the slice, we will have to go up but not include index 15. So let's test this. Okay, so we got the IP we wanted. Now if we don't specify the second index in the brackets, what would happen? Well, the string slice would start at the index given before the colon and would end at the end of the string. So it will return the rest of the string starting from the character at index 5. So let's test this. Let's delete the second index. Okay, so as I said, we got the rest of the string starting at index 5. Cool, right? Okay, what if we enter the second index, but we don't specify the first index? Well, then the slice would simply start at the beginning of the string, up to but not including the second index, whatever that index is. So let's try this. So string 1, let's delete the first index, and let's say up to index 10, up to but not including index 10. Okay, I think this returns the expected slice. This is correct. We have actually all the characters starting from index 0 up to but not including index 10. Okay, another question would be, what if we don't enter any indexes at all? Well, as you might expect, the entire string will be returned. So let's verify this. Let's delete the second index, so we have no indexes in between the brackets. So, as expected, the entire string is returned. Sweet. Now, what about negative indexes? We talked about them in the first lecture about strings. Let's try a couple of slices using negative values for indexes. String 1 of -1 will return the last character in our string, right? Okay, so this is correct. What about string 1 of -2? Well, this returns the next character when counting from right to left, so this is also true. What if we want to extract a slice containing the Ethernet part of the string, but using negative indexes? Well, we can count from right to left, starting with -1, and see what indexes correspond to the first and the last letter of Ethernet. So, this would be capital E and lowercase t. Let's count. T has index -2, right? True. What about capital E? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So capital E has index -9. Now let's write the slice. String 1. Okay, we want to start at index -9, which is the first letter of Ethernet, up to, but not including, index -1, which is the last letter, because we don't want 2 to be included in our string, in our substring. Okay, so up to, but not including -1. Okay, so this is just what we are looking for. The result is correct. We got the Ethernet substring. Now, what if we want to obtain the last 5 characters in our string? How can we do that? Well, by writing a slice with negative indexes. So, we want to start at the 5th character from the end. This means we have to use index -5 and go all the way to the end of the string. This means we don't need to specify the second index, just like earlier when we were dealing with positive indexes. So, string 1, starting from index -5 all the way to the end of the string. And it indeed returns the last 5 characters of the string. Makes sense, right? Okay. What if we want to slice string 1 starting at the beginning of the string and leave out the last 5 characters? Then we should skip the first index, since its absence means start from the first character, and go up to, but not including, index -5. So the character with the index -6 will be the last character we include in our slice. So let's test this. String 1 starting from the beginning of the string up to index -5. Okay, so this indeed returns the entire string minus the last 5 characters. Okay, this is correct as well. One more thing about slices. You can specify a third element within the square brackets after the indexes, also separated by colon. This is called a step. For example, if you would like to skip every second character of the string and obtain a new string with these elements removed, you can write the following slice. So, string 1 brackets, we type a colon because we want to consider the entire string, then we type another colon, and then 2. So we don't specify any indexes because we want to refer to the entire string, but we enter the step after the second colon to skip every second element. The result is the expected one. Notice that the new string consists of the elements with the indexes 0, 2, 4, and so on from the original string. And I think that seems correct. Okay, cool. The last thing I'll show you is how to print out the string in reverse order. For this, you should also use a slice with a step. But what would be the value of that step? Well, since we want to get the string in reverse order, we should start with the last character of the string, right? So, let's try it. String 1, double colon, double colon. We don't specify any indexes in the beginning because we want to consider the entire string, and then -1. This is the step. With this slice, we are referring, as I said, to the entire string, starting from the end, character by character. So let's see the result. Okay, wonderful, it worked. Great. Okay, so this should be more than 99% of what you will need for dealing with strings in networking. We will use strings and string methods intensively within our applications in the last part of the course. So if you feel uncertain about any concepts related to strings, feel free to review any lecture or refer to the documentation on python.org for additional string methods. Okay, let's have a look at numbers and math operations in Python. The first thing to say here is that Python defines 4 numerical types. They are integer, float, long, and complex. The complex and long types are usually used in advanced math operations and are not of great interest for our networking needs. Instead, we will work a lot with integers and floating point numbers, and that's why we will focus on these two numerical types and their corresponding operators and functions. So let's define a variable and assign it an integer and another variable associated with a float. By the way, the float type refers to real numbers having a decimal point written in between the integer part and the fractional part. Okay, so let's get to work. Let's say num1 is equal to 10 and num2 is equal to 2.5. So we have an integer and a floating point number. Let's use the type function to confirm this. So type of num1 is indeed an integer. Type of num2 is indeed a float. Okay, now let's see some operations we are able to do using integers and float numbers. Let's start with addition. So 1 plus 2 equals 3. Let's see subtraction. 3 minus 1 equals 2. Okay. Now division. 4 divided by 2 is 2. Okay. Let's see multiplication. 3 times 7 is 21. Okay. Let's see the raising to a power. So 4 raised to the power of 2 gives us 16. Okay. Notice that for raising to a power you have to use double asterisk. Okay. Now let's have a look at the modulo operation. This means finding out the remainder after division of one number by another. So let's say 5. The percent sign is the sign used for the modulo operation. So 5 modulo 2 gives us 1 because 5 divided by 2 equals 2 and a remainder of 1. Okay, now let's see some comparison operators. So we can compare 4 to 5. So 4 less than 5, which is true. 5 greater than 4, which is also true. 4 is less than or equal to 5, true. 5 is greater than or equal to 4, also true. We can also verify equality by using the double equal sign. So 5 equals 5, true. And we can also verify that a number is not equal to another number. So 4 is different from 5, which is true. Okay, now let's go back for a moment to the division operation and assume that we are not dividing two numbers for which the division result is an integer. So let's divide 3 by 2. Usually if you divide 3 by 2, the result will be 1.5, which is a floating point number. Let's see this in Python. So 3 divided by 2, okay, it gives us 1. Why is the result 1? Wouldn't 1.5 be the correct answer? Well, you are correct, but Python version 2 rounds down to the nearest integer when the result is a float. So, to get the correct result, you should add a 0.0 either to the numerator or to the denominator of the fraction. So Python will return a float as a result. So, if we divide 3 by 2.0, which is a floating point number, Python will return the correct result, which is 1.5. This is valid the other way around too, so 3.0 divided by 2, it also gives us 1.5. Okay, now let's talk a bit about the order of evaluation for these operators inside a mathematical expression. What if we have to deal with multiple operators? Well, the order is the following. Raising to a power has the highest priority in an expression. This means it will be evaluated first. Then we have multiplication, division, and modulo with equal priorities. And last we have addition and subtraction, also with equal priorities. Let's see an example. Let's say we have 100 minus 5 raised to the power of 2 divided by 5 times 2. What would be the correct result here? Well, Python will first evaluate 5 raised to the power of 2, which is 25. Then, since division and multiplication have the same priorities, they will be evaluated from left to right. So 25 divided by 5 will give us 5. Times 2 will give us 10. And finally, subtraction, having the lowest priority, will be evaluated last. So we will have 100 minus 10 from here will be equal to 90. So let's check this. Okay, correct. Now let's look at two number type conversions. Let's see how can we convert an integer to a float and vice versa. Well, Python has two functions for these operations. Let's see them. First, we have the int function. So let's type int of 1.5. It will give us 1 because it will round down to the nearest integer. Now let's test this the other way around. Float of 2 will give us 2.0. It will add the 0.0, converting 2 to a float number. Finally, let's look at a few more functions which may come in handy in the future. First, the absolute value. This is the distance between the number in the parentheses and 0. The function for this is called abs. So abs of 5 will give us 5 because 5 is 5 units away from 0. This is also true for abs of minus 5. The result is the same because minus 5 it is also 5 units away from 0. Okay, now comparing two numbers, finding the largest or the smallest one. Well, Python gives us two functions for this as well. First we have the max function. So max, open and close parentheses, and in between the parentheses we must type the two numbers we are comparing. So let's say 1 and 2 separated by comma. It will give us 2 because 2 is the largest number inside the parentheses. Also we have the min function. So min of 1 and 2 gives us 1 as expected. Finally, I will show you another way of raising to a power. It is by using the POW function in Python. So POW of 3 and 2 in between parentheses, where 3 is the base and 2 is the exponent or power. So it should give us 3 to the power of 2. It should be 9. So, okay, it is correct. I think this should be more than enough math for our networking tasks, so let's move on to Booleans. As a short definition, we can say that a Boolean data type defines only two possible values, true and false. The name comes from George Boole. He was a 19th century English mathematician and philosopher. But enough with the history, let's get back to Python. You can think of these two values like being equivalent to 1 and 0. In Python, true is written with a capital T and false with a capital F, so remember that. We have already seen true and false in some examples from previous lectures, so they are not completely new for you. Basically, they are used to test if an expression is true or false, and can be further used in conditional or loop structures, as we will see later in the course. So, let's evaluate some expressions and see what Python tells us about them. So, first let's evaluate 1 equals 1. This is true. 1 equals 2 evaluates to false. Let's also compare some strings. So Python equals Python. This is true. What about Python equals Python with a capital P? Well, this is false. Okay, let's compare 2 is less than or equal to 4. This is also true. Okay, you get the idea. So these were some basic evaluations. Now, there are three main Boolean operations that use the following operators. The first operator is AND. The second operator is OR. And the third operator is NOT. AND means that both operands should be true in order to get the expression evaluated as true. So, let's see this in practice. Let's do an AND operation between two true expressions. So, 1 equals 1 and 2 equals 2. These are both true, so the final result is also true. You can skip the parentheses, I just use them for better readability. When doing an AND between two false expressions, the result will be false. So let's test this. Let's say 1 equals 2 and 2 equals 3. Both expressions being false, the final result is also false. The third case, when one expression is true and the other expression is false, will also result in false. So let's say the first expression is true and the second expression is false. So in this case, the overall result is false as well. The conclusion here is that when using the AND operator, if both expressions are true, the result will be true. If at least one expression is false, then the result will be false as well. Now let's study the OR operator. OR means that if at least one of the expressions evaluates to true, then the final result is true. If they are both false, then the final result will be false as well. So when using OR, it is enough if only one expression is true in order to have true as the final result. So let's see this in practice. Let's use 1 equals 1 or 2 equals 2. So both expressions are true. The final result is true. Now let's use one expression which is true and one which is false. So in this case, the overall result will be true as well because, as I said, OR needs at least one of the expressions to be true. Now, if both expressions are false, the final result, as expected, will be false. Finally, using the NOT operator means denying an expression. If that expression is true, then denying it will result in false, right? And vice versa, of course. So let's verify this. NOT 1 equals 1, which is a true expression, will result in false. And if we negate a false expression, so NOT 1 equals 2, this will result in true. Okay, one more thing to keep in mind here. Some Python values always evaluate to false. These values are the following. The none value, 0 as an integer, 0.0 as a floating point number, 0 and a capital L as a long number, 0j as a complex number. Then we have the empty string, the empty list. These are structures that we're going to talk about later in the course. Empty tuple and empty dictionary. These will all evaluate to false. Okay, now Python provides the bool function to help us evaluate values and expressions. So let's use it to check the always false values. So bool, open and close parentheses, and check the none value. And we get false. Let's also check bool of 0, also false. Bool of 0.0, which is also false. Okay, you get the idea. All other values in Python are considered true. So let's do a bool of 1 is true. Bool of 22.2 is true. Bool of Cisco is true. Bool of empty string is false. Okay, so I think this is pretty intuitive. Booleans and logical operators are very useful in Python, and we will see that in the control flow section of this course. Next, we will study list concepts and operations, which are a core topic in Python. Okay, lists. Big topic ahead. So, what exactly is a list? A list is actually a sequence consisting of elements separated by comma and enclosed by square brackets. You can have any data type as an element of a list, strings, numbers, or even other lists, and any number of elements within that list. Similar to strings, which can also be regarded as sequences of characters, lists are indexed, meaning each element has a position in the list starting from 0. You can also use the len function to see the number of elements in the list, and slices to extract only a portion of that list. As opposed to strings, lists are mutable, meaning that you can modify a list by adding or removing elements. And we will see and use that a lot throughout this course. Now let's create our first list. We will name it list1. So list1, and will be initially empty. So list1 equals just the square brackets. Let's see it. Okay, so to have an empty list, you just have to type the square brackets and that's it. To check that this list is indeed a list, let's use the old type method on list1. So, type of list1. Okay, good. Now let's add some elements to our list. So list1 equals Cisco, Juniper, Avaya. Let's also add some numbers, 10, 10.5, minus 11. Okay, that should be it. So here we have a list with some networking vendors and some numbers just to show that we can add any data type to a list. So let's see list1 again. Okay, now let's remember the len function from the string section and use it on our list. So len of list1. Okay, so our list has 6 elements, which is correct. Now let's see how can we access elements inside the list. Well, the same as we did with characters in a string, using indexes. So list1 of 0 will return the first element in the list. List1 of 1 will return the second element of the list. What about list1 of minus 1? Of course, we return the last element in the list, which is minus 11. What about list1 of minus 2? 10.5. Okay, this is correct. As with strings, if we enter an invalid index, we will get an index error, stating that the list index is out of range. So let's see that. List1 of 100. Okay, so we have an index error and list index out of range. To check that lists are indeed mutable, let's try to replace an element in the list. So we still have list1. Let's see list1 of 2. We return a via. Okay. Now let's replace this element with another vendor, let's say HP. So we just have to use the equal sign to modify this. So list1 of 2 equals HP. Now let's check list1 again. Okay, so this is how you can update a list. Okay, now as a short review, the first element of the list has the index 0, always, and the last element of the list has the index minus 1. Also, remember that lists are mutable, and I hope this is clear and we can move on to list methods. Now let's see how to handle list and list elements, and what tools does Python provide for this. We've seen the len function being used on a list. But what if you want to find out the maximum or minimum value within a list? Well, you have the max and min functions available for that. So, let's see our list again, list1. Okay, let's do a min on list1. Okay, we get minus 11, which seems about right, since it is the only negative value in the list. Now let's see the max function on our list. Okay, Juniper, well, wasn't this supposed to be the 10.5 value? You see, Python evaluates string values as being larger than any number values. This is how it does it, and we have to accept it. Remember the max function we used to compare two numbers? Well, let's use it to compare a number and a string so we can have this clear in our minds. So, max between 1 and the string a. So we get a. So, take this as a rule when comparing strings and numbers from now on. Okay, now let's check the available list methods we have in hand. First, we should learn how to append an element to a list. It's simple enough. So we have list1. We just have to use the append method for this. So list1.append, and let's append the element 100. Let's check list1 again. Okay, so we can see 100 being added to the list. Nice. Now let's remove an object. We have three options here. First, we can use the following command: del and list1 of, let's say, 4, index 4. So we are deleting the element at index 4 in our list. So let's check this, list1. So we can see that 10.5 was removed from our list. Nice. Another way to remove an element by its index is using the pop method, like this. So list1 dot pop, open and close parentheses, and here you should specify the index of the element you want to remove. So let's say pop of 0 should remove the Cisco element from the list. So let's check this. Okay, this is correct. The third way is to actually remove an element by specifying the element name, the element value itself. This is done with the remove method. So list1 dot remove, dot remove of, let's say, HP. Now let's check list1 again, and HP was indeed removed from the list. Okay, now let's see how can we insert an element at a particular index into the list. So we can use the insert method, like this, list1 dot insert. First, you should specify the index at which you want to introduce your new value, so 2, then a comma, and then the value of the new element. So let's say Nortel. Okay, let's check the list1 again. Okay, so we see Nortel being inserted at index 2 in our list. Nice. Another interesting method is appending a list to another list. So let's say we have list 2 with elements 9, 99, and 999. Okay, so this is list 2. Okay. To add the elements of list 2 to list 1, we can use the extend method, like this. So we have list 1 and list 2. Okay, list 1 dot extend, and in between parentheses you type the second list, so list 2. Okay, now let's check list 1. You can see that the elements of list 2 were appended to list 1, which is what we wanted in the first place. Nice. Now, remember the index and count functions from strings? Python makes them available also for lists. So, let's find out the index of an element in our list and how to count the occurrences of an element in the list. So we have list1. Okay, let's see list1 dot index of -11. So let's find out the index of element -11. And indeed, it is index 3. Now let's append the value 10 and have this value twice in our list. So list1 dot append of 10. Let's check the list. So now we have the value 10 twice in our list. Okay, let's count the occurrences of 10 in our list. this can be done with the count method. So list1 dot count of the element you want to count. So 10. Okay, so it returns 2 occurrences of this element, which is indeed correct. Now, let's have a look at ways to sort the elements in a list. First, we can use the sort function. So, returning to list2, let's add a couple of elements first. So, list2 dot append of, let's say, 1, let's say 25, let's say 500. Okay, let's see list2 now. Okay, now let's say that we want to have them in ascending order. For this, we just have to use the sort method like this. So list2 dot sort, and that's it. Let's see list2 now. Okay, so we have them from the smallest to the largest number, ordered in this way. So it is an ascending order. Cool. What if we want the elements in reverse or descending order? Well, we have to use the reverse function for this. So list2 dot reverse gives us the reversed list from earlier. Okay, so starting with the largest element up to the smallest element in the list. Nice. As you can see, these two methods are modifying the list in place, meaning that after you apply the method, there is no other list created. You have the same list too, only that the elements are in a specific order. To sort the elements of a list and create a new list in the same time, you have to use the sorted method, or function, actually. Let's see it in action. Now, let's sort the elements in ascending order. So, sorted of list2. Okay, gives us a new list in ascending order. Nice. If you want to use the same function to reverse the order, just add an argument inside the parentheses like this. So, sorted of list2, comma, and let's add reverse equals true. Now you have the same list in descending order. Okay. By the way, you may ask me, where did the reverse equals true argument come from? Well, I knew it because I used it a couple of times, but if you want to check the syntax or available arguments for a function, you shouldn't forget the help command. So let's do a help unsorted. Okay, so you can see that the reverse equals false or true is indeed a valid argument for this function. Now type Q to exit this. Okay, two more things here. You can concatenate or repeat a list as you did with strings using the plus and multiplication operators. So let's see list1 plus list2. Okay, it gives us a bigger list. Nice. Also list2 times 3. Sorry, I forgot it too. List2 times 3 gives us list2 repeated 3 times. So correct again. Notice that here the duplicate elements are allowed, so don't worry about that. Next, we are going to discuss list slices. Remember, slices allow us to extract various parts of a sequence. We use them to slice strings in many ways. All the rules applying to string slicing also apply to list slicing. The general syntax is: first, we have the name of the variable pointing to that string or list, let's say list1, followed by square brackets. In between the brackets, we have a colon. Now, on the left side of the colon, we specify the index at which to start the slicing. So let's say index 1. Now the slice will be up to, but not including, the index specified on the right side of the colon. So let's say index 4. This would be the general syntax for list slicing. Having that said, let's create a new list and do a couple of list slices. So let's create list 3 equals to, let's add in some elements, 1, 2, 3, A, B, and C. Okay, let's see it. Nice.
What if we want to extract the first 3 elements of list 3? These would be the elements having the indexes 0, 1, and 2, right? So the slice would be from index 0 up to, but not including, index 3. Let's test this. So list 3, starting from index 0 up to, but not including, index 3. So we got 1, 2, and 3, which is the result we expected. Another way to extract the first 3 elements would be, remember from strings, not specifying the first index in between the brackets. So we just have to type in list 3 and colon 3. This also gives us 1, 2, and 3, a correct result. Now, what about extracting a slice made of the following elements: 3, A, and B? This means we have to start at index 2, corresponding to the 3 value, up to, but not including, index 5, which is the index of C. Let's verify this. So, list 3, starting from index 2, up to, but not including, index 5. So this indeed returns us 3A and B. Nice. Now let's extract all the elements starting from index 3 up to the end of the list. In this case, we don't have to enter the second index in between the brackets. So let's test it. List 3, starting from index 3 up to the end of the list. So just a colon. And we indeed get A, B, and C. Nice. For selecting the entire list using a list slice, do not include any indexes at all inside the brackets, just the colon. So as we did with strings, let's try this, list 3, and just a colon between the brackets. This returns us the entire list indeed. Now remember, we can also use negative indexes to slice a sequence. And negative means we are looking from right to left when counting. So list 3 of -1 will be, of course, C, the last element of the list. List 3 of -2 will be B, indeed. Okay, this is correct. Now, to extract a slice made of elements 3, A, and B again, we would have to start the slice at 3's negative index, which is -4, because we have -1, -2, -3, -4, up to, but not including, C's index, which is -1, because it is the last element of the list. So let's see this in practice. List 3, starting from index -4 up to, but not including, index -1. So we get 3A and B as expected. Nice. For extracting the last 3 elements of list 3 using negative indexes, we should start at what index? Well, -3, right? Because -3 means the third element from right to left. What would be the second index? Well, you guessed it, there isn't one. We go all the way to the end of the list, and that's it. So, let's see it. List 3, starting from index -3 up to the end of the list. So, it indeed returns us A, B, and C, the last 3 elements in the list. What about a slice made of all the elements of the list minus the last 3 of them? Well, just move -3 on the right side of the colon and that should do it. So let's see this. List 3, starting from the beginning of the list up to index -3. So this indeed returns us 1, 2, and 3, the first 3 elements of list 3. Okay, that's cool. The last 2 things on list slices. First, using a step for the slicing process. Like, for example, if you want to skip every second element of the list. Then you will use 2 colons inside the square brackets, and then the step you want. In our case, this is 2. So, let's try this. List 3, colon, colon, and 2. And this gives us 1, 3, and B indeed, as we expected. Secondly, if you want to see the list in reverse order using list slices, you can also use the step trick again. So this time the step value will be -1 because you want to start with the last element in the list, right? So let's try this. List 3, colon, colon, and -1. Okay, and this returns the list in reversed order. Cool. Now, next in our course, we will study sets. What is a set, you may ask? Well, a set is basically an unordered collection of unique elements. Generally, you may see sets as lists that have no duplicate elements. Let's see the way to create a set. In fact, there are two ways. The first one is by using the set function, which is a Python built-in function. To also prove that sets do not allow duplicates, let's create a list with duplicate elements and apply the set function on this list. So let's create list 4 with the following elements. So 1, 2, 3, 4, 5, 2, and 3 again. Okay, so let's see list 4. Okay, now let's apply the set function on this list. So set of list 4 returns a new list. In fact, it is a set with all the duplicate elements removed. Okay, this is nice. You can also directly create a set by passing it a sequence, like a string or a list, and storing the result in a variable. So let's create variable set1 equals to set of, open and close parentheses, and let's insert a list here with duplicate elements. So 11, 12, 13, 14, 15, let's add 15 3 times, okay, and 11 again. Close the list. Okay, now let's check set1. You can see that the duplicate elements have been already removed. Now let's do a type on set1 to confirm that it is indeed a set. Okay, nice. The second way to create a set is to use curly braces, like this. And this method of creating a set is available in versions of Python starting with 2.7, so ours is included, according to python.org, the official site. So let's create set2 equals to, and open and close curly braces. Let's say 11, 12, 13, 14, 15 3 times, and 11 again. Okay, now let's see set2. The duplicates have already been removed. Now let's do a type of set2. And Python confirms that this is indeed a set. Okay. We can also find out the number of elements in a set using the same len function as we did with strings and lists. So, len of set2. Okay, set2 has 5 elements. This is correct. Now, checking if an element is or is not a member of a set is also possible using the in and not in keywords. So, let's try this. 11 in set2. Okay, this is true. What about 10 in set2? This returns false. Okay. What about 10 not in set2? This returns true because not in negates the existence of 10 in set2. Okay. Another thing I should add is that sets are mutable, so we can add or remove elements from a set in the following manner. So we have set2. Okay. Let's add an element to set2. So set2.add. This is the method you should use. And in between parentheses, you should specify the element you want to be inserted. So now let's check set2. You can see that 16 was indeed appended to set2. Okay, what about removing an element? Well, this is simple. Just use the remove method. So remove. And in between parentheses, you will specify the element you want to be removed. So let's say 11. Let's check set2 again. And 11 was indeed removed from the set. Okay, notice that if I try to add an element which already exists in the set, let's say set2.add of 16, Python will not agree. Let's check set2. Okay, 16 is there just once. So Python doesn't agree, although no error is returned. Just that Python does not add a duplicate element to a set, and you should keep this in mind. Okay, now let's see some operations on sets. To better understand set methods and operations, let's create two sets first. I have already created them, so let's see them. Set1 and set2, both containing some IP addresses. Now, Python defines some methods for identifying the similarities or differences between two sets of elements, but also defines other methods to better make use of this data type. So let's see them. First, let's see how can we identify the common elements of the two sets we define. To do this, we can use the intersection method like this. So set1 dot intersection with set2. Okay, this is true because the IP address 3.3.3.3 is the only IP address which resides in both sets. Also, this operation can be done the other way around, so set2 dot intersection with set1 returns the same result. Nice. Now, let's see which elements does set1 have and set2 doesn't. This is done by using the difference method. Looking at the two sets, we notice that set1 has the addresses 1.1.1.1, 2.2.2.2, and 4.4.4.4, but set2 does not. So this should be the final result. Let's check it. Set1 dot difference from set2. And indeed, we confirm our result. Of course, this can be done vice versa, so set2 dot difference from set1. This time we get the IP addresses which reside in set2 but not in set1. So the result is correct again. Now, to unify two sets, you can use the union method. And the result, also being a set, will include the 3.3.3.3 address just once. So do not confuse it with concatenation. Let's say this. Set1 dot union with set2. So now we have a bigger set containing all the IP addresses. Okay, another thing you can do is remove a random element in the set. This is done by using the pop method. So let's see set1. Okay, let's do a set1 dot pop. Okay, pop removes displays and removes the 1.1.1.1 IP address. So let's check set1 again, and indeed that address is removed. Okay, finally you can clear a set using the clear method. So let's see set1 again. Okay, let's do a set1 dot clear and check the results. Now, as we might expect, we have an empty set, so set1 is now empty. Nice. There are other methods for sets in Python, but the chances you will need them are not that high, so we won't discuss them in this course. Just in case, you can find a link to Python's official documentation regarding sets in the additional resources section of this lecture. The tuple is another sequence data type in Python. You can consider tuples as being immutable lists, meaning their contents cannot be changed by adding, removing, or replacing elements. Tuples may be useful when you want to store some data in the form of a sequence and keep that data untouchable. Okay, enough with the theory, let's start to practice and create a tuple. Tuples are enclosed by parentheses and their elements are separated by commas. So let's create myTuple equals open and close parentheses. Now let's confirm that this is indeed a tuple, so type of myTuple. Okay, so the tuple type is confirmed. Now this is an empty tuple. What if you want to have a tuple with a single element? Well, to create such a tuple, you have to use a trick, meaning that although you have only one element inside the tuple, you have to write a comma after it, otherwise it will not be regarded as a tuple. So let's see this. If we create my tuple with a single element, that being, let's say, 9, without the comma trick I told you about, now Python will regard this as an, let's see, integer. Okay, that's not what we want. We want a tuple. So let's try this again, this time with a comma after this element. So let's use the type function again. Okay, and this time we indeed have a tuple. Okay, next let's populate our tuple with some elements. So let's say my tuple equals 1, 2, 3, 4, 5. Okay, so let's see my tuple. Okay, tuples support indexing, like strings and lists. So if you want to access an element in the tuple, the same indexing rules are applied. So let's try this. First, let's see the first element in the tuple. So my tuple, of 0 gives us 1. Correct. My tuple of 1 is 2. Nice. Now let's try also negative indexes. So my tuple of -1 gives us the last element of the tuple, so 5 minus 2 will be 4. Okay. Now, tuples being immutable, you cannot add or modify an element of a tuple. So let's verify this. My tuple of 1. Let's try to change the element at index 1 equals 10. Okay, so Python gives us an error, a type error, and tells us that a tuple object does not support item assignment. Okay. Also, removing elements is not permitted with tuples. So let's try to delete the element at index 1. Del my tuple of 1. Okay, so this time Python tells us that tuple object doesn't support item deletion. Nice. Another interesting thing you can do with tuples is tuple assignment. This means you assign a tuple of variables to a tuple of values. So let's see this. Let's say we have tuple 1 equals to Cisco 2600 and an iOS version, let's say 12.4. Okay, so this will be tuple 1. Now let's assign another tuple, a tuple of variables, to the tuple we created. So let's create the following variables. Let's say vendor, model, and iOS in a form of a tuple equals tuple 1. Okay, now let's see if indeed the variables in the tuple of variables were associated with the values in tuple 1. So let's see the value of vendor. Okay, so this returns Cisco. Very nice. Let's also see the model variable and the iOS variable. Okay, works as expected. This is called tuple packing and unpacking, and you can see it as a kind of mapping between elements of a tuple and elements of another tuple. An important thing to remember here is that both tuples should have the same number of elements, so if you have different number of elements, a value error will be returned. So let's say tuple 2 has the following elements 1, 2, 3, and 4. And let's say we want to assign a tuple of variables composed of x, y, and z variables to this tuple we created, tuple 2. We will get an error saying that there are too many values to unpack. So you cannot assign a tuple with a number of elements to a tuple with a larger or a smaller number of elements. Okay. Now you can assign values in a tuple to variables in another tuple within a single statement. So let's try this. Let's try a, b, and c equals to 10, 20, and 30. Now let's check the value of a is 10, b is 20, and c is 30 as expected. Nice. Now let's see some operations on tuples. As with strings and lists, we can use some basic operations on tuples too. So we can use the len function to find out the number of elements of the tuple. So let's create tuple 2 with the following elements, so 1, 2, 3, and 4. Now let's do a len on tuple 2. It should return 4, because this is the number of elements in tuple 2. Nice. Also, we have the min and max functions available. So let's do a min on tuple 2. Indeed, 1 is the smallest integer inside the tuple. Now a max on tuple 2. And of course, 4 is the largest number in the tuple. We can also concatenate and multiply a tuple using the same old plus and multiplication operators. So we have tuple 2. Let's concatenate tuple 2 with another tuple. So let's say 5, 6, and 7. So now we have a larger tuple including those elements. Now let's see tuple repetition. So tuple 2 times 4. We have a larger tuple with the elements of tuple 2 written 4 times. Okay. Now, since indexing applies to tuples as it does to strings and lists, slicing is also possible for tuples. Let's see a couple of examples without entering into slicing details again, since the rules are identical. So, we have tuple 2. Let's do a slice on tuple 2. So let's start at index 0 up to, but not including, index 2. So we have 1 and 2. These are the elements at indexes 0 and 1. Nice. This is the same thing as writing just a colon and the index 2. Sorry. Okay, so we got the same elements. Now let's try tuple 2, starting from index 1 to the end of the tuple. So just the colon. Okay, so we get 2, 3, and 4 as expected. Now to return the entire tuple using a slice, we just have to type in the colon in between brackets. Sorry, I keep forgetting the 2 in tuple 2's name. Okay, also we can use negative indexes. So let's say tuple 2 of -1 is 4. Okay, the last element in the tuple. Let's see tuple 2 starting from the beginning up to index -2. So this returns the tuple minus the last 2 elements, which is also correct. Okay, let's also use a step. So tuple 2, colon, colon, and -1 to display the tuple in reverse order. So here's the result, and it is correct indeed. Another thing you can do with tuples, you can check if an element is a member of a tuple or not, using the same in and not in keywords. So let's see this. We have tuple 2. Let's try 3 in tuple 2. This is correct. Let's try 5 in tuple 2. This is false. And let's try 5 not in tuple 2, which should be true. And indeed it is. Nice. Now, last thing on tuples, we can use the del command to delete the entire tuple. So, we have tuple 2. Let's do a del on tuple 2. Now, let's check tuple 2 again. So, name tuple 2 is not defined. This means that tuple 2 does not exist anymore. Okay, tuples will be very useful in our networking adventure. Maybe we will not use them as much as lists, but you should definitely keep them in mind. Next, we will look at dictionaries, another key data type in Python. Okay, let's see the last data type that we'll need for our Python networking adventure, dictionaries. A dictionary is an unordered set of key-value pairs, separated by commas, and enclosed by curly braces. They are very useful for storing information in a pair format. Like for example, for a router, we can store data in the following form. Vendor, Cisco. Model, 2600. iOS 12.4, and so on. Now, dictionaries are mutable, which means we can modify their contents using dictionary-specific methods. Why do I say dictionary-specific? Because, unlike strings or lists, dictionaries are not indexed by element position, like we had 0 for the first element, 1 for the next, and so on.
Dictionaries are indexed by the key. This is the value on the left side of the column. We will see this in practice, don't worry. For now, let's just create an empty dictionary. So let's go ahead and delete this. Let's say dict1 equals open and close curly braces. Let's see dict1. Now let's do a type on dict1 to confirm that it is indeed a dictionary. So type dict, okay. This is how you define a dictionary. Now let's add some data to it. So let's say dict1 equals vendor Cisco model, let's say 2600, iOS version, let's say 12.4, and lastly the number of ports, 4 ports. Okay, close the curly braces, and that's it. Let's see dictionary dict1. Okay, now each dictionary element is made of a key, a colon, and a value, then followed by a comma, and then you type in the next element, and so on. Now let's notice a few things here. First, because the keys in this case are actually strings, each key is enclosed by quotes, single or double quotes. This may be the most widely spread data type for a key in a dictionary. You may also use a number as a key in order to have some kind of numbering system, like this. So let's create dictionary d1 equals, let's say 1, first element, and 2, second element, and so on. Let's see, D1. Okay, now returning to our dict1 dictionary, let's see it one more time. Another thing to notice is that although when we created the dictionary we entered the vendor Cisco pair first, then the model pair, then the iOS pair, and lastly the ports pair, when we are displaying the dictionary they are ordered in another way, at random. This was what I meant when I said that a dictionary is an unordered set of key-value pairs, so keep this in mind. Don't worry, dictionaries are not so chaotic though. Python helps us a bit when using dictionaries. We will see how in the next lecture. A key thing to remember is that each key in the dictionary must be unique and should be an immutable type. This means you can have strings, numbers, or tuples as keys, but not lists. On the other hand, values don't have to be unique and can be either of an mutable or an immutable data type. Let's return to the dict1 dictionary from the previous lecture and see how can we work with it. So we have dict1. This is it. First, let's extract a value for a specified key. This can be done similar to accessing elements in a list, only that we don't specify an index. We specify the associated key for the value we want. So let's say dict1 of iOS returns the value for the iOS, which is 12.4. Okay, let's try this for the vendor key. And we get Cisco back. Okay, great. In the previous lecture, I said that dictionaries are mutable. So let's try to add a key value pair to our dictionary. This is done by simply assigning a new value to the new key, like this. Dict1 of, let's say, rem equals, and the value for this key, let's say 128. Now let's check dict1 again, and indeed our dictionary was updated with the new key value pair. Now notice that the pair we added is not appended at the end of the dictionary, because dictionaries are unordered, remember? Okay, now maybe we want to modify the value for the iOS of this Cisco router. Well, how can we do this? It's simple. Just use the same syntax as for adding a pair. So let's do a dict1 of iOS equals, and then you type in the new value. Let's say 12.3. Let's check the dictionary again. And indeed, the value was updated for the iOS key. Okay. We can also delete a pair in the dictionary using the del function. del of, let's say, dict1 of ports. Now let's check the dictionary. And indeed, the ports key value pair is gone. Now, remember the len function from strings, from lists and tuples? We can use it here to find out the number of key value pairs within a dictionary. So we have dict1. We have 4 key value pairs, as we can see. Let's type len of dict1, and it indeed returns 4 as the number of elements in this dictionary. Okay, correct. Of course, you can verify if a value is a key in a dictionary or not, like this. Let's say iOS in dict1 is true. Okay. Let's say iOS2 in dict1. This returns false because iOS is not a valid key in our dictionary. And for the same reason, iOS2 not in dict1 returns true. Now, there are 3 important methods to deal with keys and values in a dictionary. The first method is the keys method. This is used to obtain a list having the keys in a dictionary as elements. A similar method is values, to get a list of dictionary values. Now let's see both of them. So first, dict1 dot keys indeed returns a list of the keys in this dictionary. Now let's see dict1 dot values also returns a list, this time a list made of the values in the dictionary. Okay. The third main method here is the items method, which returns a list of tuples, each tuple containing the key and value of each dictionary pair. So let's check this out. dict1.items. Okay, so we indeed got a list of tuples, each tuple containing a key value pair in our dictionary. Now we should expand a bit on the order of elements in a dictionary. Even if the dictionary stores the key value pairs in a different order than the order you specify them, when using the keys, values, and items methods, Python keeps track of the order in which it stored the pairs and displays the keys, values, or pair tuples in the same order. So let's see this in practice. Let's check dict1 again. Sorry. Okay. This is the order of pairs in our dictionary. Now, let's check the order of elements in the lists generated by the 3 methods. So dict1.keys, dict1.values, and dict1.items. You can see that Python helps us a bit when dealing with dictionaries by keeping an internal indexing system when using dictionary methods. From these 3 methods we applied on dictionary dict1, we can see that Python indeed keeps track of this index and this order in which you can access elements in the dictionary. Okay, I think this should cover most of what you need on dictionaries to get things going. The last thing I should cover on the data types topic is conversions between data types. This means that we will see how to convert from one data type, a number for example, to another data type, like a string. There are specific functions that accomplish this task, so let's see some of them in action. First, let's try to convert an integer or a float number to a string. This is done using the str function. So let's say we have a variable num equals to 2 and another variable flt equals to 2.5. Let's do a type on each of these variables. So type of num is an integer and type of flt is a float. Okay. Now let's convert these to strings. So let's create num1, a new variable, and apply the str function on num. So num1 equals str of num. Now let's see num1. Notice that 2 is already enclosed by quotes because it has already been converted to a string. Let's confirm this with the type function. So type of num1, it is a string. Let's do the same thing on FLT. Let's create FLT1 equals str of FLT. Let's check out FLT1. You can see the quotes again. Let's do a type on FLT1. And indeed it is a string. Now let's try this backwards and convert a string to an integer. Let's create variable str equals to 5 in between double quotes because this is a string. Now let's create str1 equals, the function to convert a string into an integer is named int. So int of str. Let's check out str1. You can see that 5 is not enclosed by single or double quotes. Let's do a type on str1. And we indeed have an integer now. Okay. You can also convert integers to floating point numbers and vice versa. So we still have num in memory. It is 2. Type of num, it is integer. Okay. Let's create another variable. Let's say f equals to float. This is the function. Float of num. So we apply this function to the num variable. Let's check out f. Now you can see that it is 2.0. Let's do a type on f. And we can see that this is indeed a float. Okay. Now the other way around, we have FLT 2.5. Let's create another variable. So f1 equals, to convert a float number to an integer, use the same int function as earlier. So int of FLT. Now let's check f1. Okay, so type of f1. This is now a string. Okay, notice that applying the int function on a float will return the integer part of that number. In our case, 2. So keep this in mind. Now moving to sequences, let's convert a tuple into a list using the list function. Let's say we have top1 equals 1, 2, 3. Let's see top1 and type of top1. Okay, this is a tuple. To convert it to a list, use the list function. So let's create a new variable. List1 equals list of top1. Let's see list1. Okay, this is indeed a list. Let's do a type on list1. And Python confirms that this is indeed a list. We can also convert a list into a tuple using the tuple function. So we still have list1 in memory. Okay, 1, 2, 3. Let's create a variable. Let's say top equals tuple of list1. So this is the function you should apply when converting to a tuple. Okay, let's see the top variable. Okay, 1, 2, 3. Let's do a type on top. Okay, this is a tuple. Nice. We have also seen how the set function works, turning a list into a set. So let's say we still have list1 here. Okay. Now let's create variable set1 equals set of list1. So applying the set function will turn list1 into a set. Let's see set1. Okay, let's do a type on set1. And it is indeed a set. Now, the last thing I'll show you here is how to convert between different numerical representations of numbers. And I am referring to decimal, binary, and hex notations. So base 10, base 2, and base 16 numbers. Now let's say we have a variable num equals to 10. Let's convert 10 to binary. First, let's create another variable num underscore bin equals to, and now we should use the bin function, like this, bin of num. Let's check out num underscore bin. Okay, this is the binary representation of 10. Cool. Now let's do the same thing for hex. So let's create a new variable num underscore hex equals to, and now we will use the hex function on num. So hex of num. Let's check out num underscore hex. And this is the hex representation of 10. Cool. Now to convert from binary and hex back to decimal notation, we will use the same old int function, like this. Let's create a variable bin to num equals int of num underscore bin, comma, and a 2, where 2 is the base we are converting from. Okay, so let's check out bin to num. Okay, we got 10 back. Now the same thing for hex, so hex to num equals int of num underscore hex, comma, and 16. 16 being the base we are converting from. Remember this. Okay, now let's check hex underscore to underscore num, and we get 10 back again. Okay, now that's about all you need to know about data types for your Python adventure into the networking world. Of course, there are many other functions and methods we can discuss, but you will use them very rarely or even not use them at all. Now let's get on to the next section and discuss about control flow. In Python, we have the if, elif, and else statements for decision making. Using these statements, Python evaluates expressions and runs a piece of code accordingly, meaning if an expression is evaluated as Boolean true, then the code indented below the if statement will be executed. Otherwise, Python goes further and evaluates elif or else statements, if any. Unlike many other programming languages that use curly braces or other delimiters, Python uses indentation to define code blocks, meaning if, for, and while statements, functions, or classes. Using indentation means that white spaces are used as delimiters for code blocks, and here I'm referring to both space characters, usually 4 of them, and the tab key. We are going to see that from now on in the course. Just remember that you should stick with a convention for using indentation, and not mix spaces and tabs within your code. We are going to use the tab key each time we want to indent some piece of code. I think this is the safest way to do it. Another thing to remember is that after every if, for, or while statement, or function, or class definition, you must use a colon so that Python will know that it should expect an indented block after that statement. Don't worry, you will easily get used to Python's way of writing code. Now let's start working with if, elif, and else statements. Let's say we define a variable x equals to 10, and we want to make a decision based on that variable's value. Maybe the value will change at some point and we want to handle that change in some way. Let's use the if statement to execute a block of code if the expression we provide will be evaluated as true. So, if x greater than 5, colon, print x is greater than 5. Okay, now let's stop for a moment and see what we have here. First, I typed the if keyword, then the expression I want to evaluate, so x greater than 5, and then a colon. Being in the Python interpreter, you can see that Python recognizes that a block of code is expected, So it will show the three dots we have already seen when printing on multiple lines in the string section. At this point, I hit the tab key, so the code I want to execute, if that expression is evaluated as true, will be associated with the if statement above. Finally, I wrote that the program should print a string if x is greater than 5, and then hit enter twice. And of course, since 10 is greater than 5, it printed the user-defined string. Good. Now, what if x would have been equal to 4? Let's test this. So x equals 4. Now, if x greater than 5, print x is greater than 5. As expected, our if block does not return anything, since 4 is not greater than 5. As a tip, you can use the up arrow key to avoid typing the commands again. Okay. So what happened here from Python's point of view? It's simple. Python evaluated the x greater than 5 expression. When we define x as being equal to 4, the expression will be evaluated as false. We can check that in the interpreter. So x greater than 5 returns false. If Python evaluates the expression as true, it will execute the indented code below the if statement. Otherwise, it will skip it and move on with the rest of the code. Now, what if you want to handle multiple cases? Let's say you want something to be printed out regardless of the true or false result of the evaluation. Then you will use the elif or else statements. First, let's see how to use else and return to our variable x, which is still equal to 4. Let's print x is greater than 5 if x is indeed greater than 5, and x is not greater than 5 in any other case. This will be accomplished in the following way. So, if x is greater than 5, let me use the up arrow key, print, OK. Now, else, a colon, and let's say print x is not greater than 5. OK. So to specify the else statement, you must hit enter after print x is greater than 5. Then type the else keyword, followed by a colon and an enter. Now for the code to be executed if x is not greater than 5, you should hit the tab key and thus indent another block of code. In our case, we want to print x is not greater than 5. See how that works? For every block of code we want to be executed, we must use indentation. The else statement is used to cover all other cases which are not covered by the if statement above it. So if the expression following the if keyword is true, the indented code below it will be executed. Otherwise, if it's evaluated as false, the indented code below else is executed. But what if we want to be more granular and specify more cases and possible outputs in our program? Then we could use an elif statement like this. Let's say we want to print x is greater than 5 if x is indeed greater than 5. Then print x is equal to 5 if our x variable will have the value 5 at some point. And finally, x is less than 5 for all other cases. We can add the elif statement in between if and else. Remember that else should always be the last statement. So let's set x equals to 5 and modify our if else block. So let's use the up arrow key. Okay, print x is greater than 5. Now let's type the elif statement. So elif x equals 5. Print x is 5. And finally else print x is not greater than 5. So the syntax for elif is similar to the syntax of the if statement. Notice that when evaluating equality between two operators, we use two equal signs because this is not an assignment operation like x equals 5 at the beginning of our example. As a rule, keep in mind that elif and else statements are optional, so you can just have an if statement, evaluate an expression, and execute some code or not without covering other cases. You can have as many elif statements as you want after an if statement, but remember that there can be only one else statement at the end, covering all cases uncovered by the if and elif statements. Another thing here is that there may be more than one evaluated expression after the if keyword, and more than one line of code inside the elif and else blocks. So let's see an example. We know that the value of x is 5, and Python identified x as an integer due to this assignment. So if we check that type of x is integer, Python should return true. So we have x equals 5. This is true. And type of x is int, also returns true. So we have two expressions evaluated as true. Let's use them inside an if block. To check if both expressions are true, we will use the AND logical operator. To execute some code if at least one of the expressions is evaluated as true, we will use the OR logical operator. So we have x equals 5, true, okay. If x equals 5 and type of x is int, then a colon, let's use print x is greater than 5. Let's also print x. Then let's insert an elif statement, elif x equals 10 and type of x is int. Print x is an integer but is not equal to 5. Okay. First, notice that we don't have an else statement. That's because it is optional. Secondly, notice Python printed the string in the if block because both expressions are evaluated as true, which leads to a final value of true. So Python executes the indented code below if and exits without checking other expressions below. If the expression in the if statement would have been evaluated as false, then Python would have jumped to the elif statement and then to the next one and maybe to a final else statement until it would find a true expression being evaluated and execute that code over there. Now let's do another test. Let's set x equals to 10. Okay, so this time if x equals 5 and type of x is int, let's use the same string and print x, then the same elif statement and the same print statement associated with this elif. Okay, this is it. In this case, the expression in the if statement is evaluated as false, since we have the AND operator, and one of the operands is evaluated as false, this operand, because now we have x equals 10. Because this is false, Python jumps to the next statement, the elif, and the result of evaluating the expression is true, since both x equals 10 and type of x is int are true expressions. For this reason, Python executes the indented code below the elif statement as expected. But what if neither expression is evaluated as true and we don't have an else statement to cover all other cases? Let's see. Let's set x equals to 100. Now let's use the same code that is above. So let's use the up arrow key. Okay. Print x. Now the elif statement and the final print statement. Okay. In this case, Python returns nothing. If we would have had this if-elif block inside a larger program, then Python would have jumped to the rest of the code, as if this block was not even present in the code. So, remember that Python handles if, elif, else blocks in order from top to bottom until it evaluates an expression as true. As soon as it finds it, it executes the indented code below it and jumps outside the block to the rest of the code without evaluating other elif or else statements. The for statement is used whenever you want to iterate over a sequence and execute a piece of code for all or some elements of that sequence, list or string or whatever sequence you have. Let's start with an example of iterating or looping over a sequence. And first, let's define a list. I have already defined it. It is called vendors. Let's see it. Okay. Now let's see how can we make the for statement helpful to us. First, you will notice that there are some similarities to the if, elif, else syntax, meaning that the colon is again used to signal that an indented code follows the for statement. And speaking about indentation, we must indent the code inside the for loop using the tab key to separate it from the code that follows and is not part of that for statement. Let's better see this. We start by typing the for keyword. Then we enter the iterating variable, which is user defined, so you can name it however you like. Let's name it each vendor. Then we type the in keyword, so in, to specify that we are going to iterate over the sequence following this keyword. And finally, the sequence itself, followed by colon. So, vendors and a colon. Okay, then a tab, let's say print each vendor. So I named my variable, my iterating variable, in such a way that it reflects my specific need. In this case, each vendor. Then I told Python that it should assign each element in the list to the iterating variable and execute the indented code below for every element until all the elements in the list are exhausted. So Python did this and printed each list item. Of course, you can have multiple lines inside the for block as with the if, elif, and else statements. We can also iterate over a string. Let's see this. Let's create myString equals Cisco. Okay. And let's say for letter in myString. Okay, print letter, then another tab, print letter times 2, and print letter times 3. Okay. So first we assign a value to the myString variable. Then, using a for statement, we assign each character in the string to the letter variable, and for each time we do this, Python executes the indented code block below the statement. So, for each letter of Cisco, Python prints out the letter itself, the same letter doubled and then tripled. Now it's time to talk about two Python functions that are frequently used with for loops, range and xrange. Let's have a look at the range function for now. The range function does nothing more than just creates a list using a value we specify in between parentheses. So let's try it and see how it works. Let's do a range of 5. Okay, now let's do a range of 10. So after passing an argument of type integer to this function, Python creates a list starting from 0 as the first element and going up to, but not including, the integer we give as an argument. So it stops right before that value. But what if you don't want to start the list from 0? Then you should specify a starting point, like this. Let's say range of 5, comma, 10, where 5 is the starting point, and the list will go up to, but not including, 10. Let's see this. Okay. Now what if you want to skip some elements and specify a step to increment by? Maybe you want to get the odd numbers between 1 and 10. You can do the following. Range of 1, comma, 10, comma, 2, where the third element in parentheses is actually the step value. So we got the odd elements between 0 and 10. Nice. Now, as I said, there is also the xRange function available in Python. The difference is that while range creates the entire list from the very beginning, xRange creates the list elements as they are needed. So it is more memory friendly than the range function. Now let's see an example of a for loop using the range function. Let's say for I in range of 5, a colon, then a tab, print I times 2. So we used for to loop over the list created by the range function, and for each element print out its value multiplied by 2. Nice. Now let's see a more common use of the range function inside the for statement. What if we want to iterate over a list using list indexes? Let's see what do I mean by that. We still have the vendors list in memory, so let's see vendors. Okay. Now remember the len function from the previous lectures? Let's apply it to our list. So len of vendors equals 5, because we have 5 elements in the list. We know that range of 5 returns a list starting from 0 up to, but not including 5. So let's check this. Range of 5. Okay. We can look at the elements of this list as being the indexes of each element of our list, vendors. So the element Cisco would have index 0. The element HP would have index 1, and so on. This means that if we want to get a list of indexes to iterate over using the for statement, we can use range of len of vendors, right? To obtain that list. So to use this in practice, let's create a for loop which prints out each element of the vendors list by its index. So for element index in range of len of vendors, tab, and let's say print vendors, and in between square brackets element index. So what we did here is we passed the result of one function, len, to another function, range. The result was the list of all indexes in the vendors list, depending on its length, of course. We then assigned each index value in this list to the element index variable and executed some code for each index. In translation, we told Python to check the length of vendors, get all possible indexes in the list, and then execute the for statement further. Python created the 0, 1, 2, and 1, 2, 3, and 4 list, and then printed out each element, vendors of 0, vendors of 1, and so on until the list was exhausted. Another very useful way to iterate over a sequence is by using both the index and the element value as iterating variables. This can be achieved using the enumerate function in Python. So let me first write this. So let's say for index, comma, element in enumerate of vendors. Let's say print index is, and let's use a format operator to remember it from earlier lectures. Index, and also print, let's say element is, and we will use the format operator for strings, the %, and the element variable. Okay, so using this method, Python returns both the index and the element value at the same time. Cool. The last thing I'll add here is that you can also use an else statement for the for statement. The indented code below else will be executed when for has finished looping over the entire list. So let's try this. For element in vendors, let's say print element. Then else, a colon, then a tab key, and let's say print the end of the list has been reached. Okay, so as you can see, this for else block prints each element in the list, and finally it prints the string below the else statement, which is what we wanted in the first place. That's about all you have to master when talking about for loops. We will use them widely across our applications, so you should have a very good understanding of them before moving to the application building part of the course. The second type of Python loops is represented by the while loop. What is the difference between for and while loops, you might ask? Well, unlike a for loop, which executes a block of code a number of times, depending on the sequence it iterates on, a while loop executes as long as an user-specified condition is evaluated as true. If the specified condition does not change, meaning it doesn't become false, then the loop will continue executing forever, and we end up with an infinite loop. When the condition becomes false, Python continues to execute the code following the entire while loop. Now let's see an example of a while loop. First, let's define x equals 1. To create a while loop, you have to type the while keyword, followed by the condition you want to evaluate, and then a colon. Below, using tab for indentation, you specify the code to be executed as long as the condition is evaluated as true. So, let's say while x is less than or equal to 10, colon, tab, let's say print x, and x equals x plus 1. This means that after printing each x that is less than or equal to 10, we want to increment x by 1 and evaluate the next value. So Python takes the first value of x, which is 1, evaluates it against the condition as true, prints it to the screen, and then increments it by 1. Now, x being 2, it is again compared to 10, and the evaluation result is again true. Then it is printed out and incremented, and so on, until x reaches 10. When x reaches 10, the condition is still true because 10 is less than or equal to 10. Then the value is printed out and then incremented to 11. When evaluating 11 less than or equal to 10, Python returns false and exits the loop without printing or incrementing the value of x further. But what would happen if we don't specify the statement that increments x? Well, let's think. X is initially equal to 1. It is compared to 10, and the expression returns true. So it is passed to the code below. It is printed out on the screen, but this time there is no statement to increment it. So it keeps its value of 1 and it is again compared with 10. The condition being met again, it is passed to the code below and so on forever. Let's test this. Because we'll end up with an infinite loop in the interpreter, you can use Ctrl plus C a few times to interrupt the loop. So let's initialize x with a value of 1. Now while x is less than or equal to 10, let's print x. As you can see, we are now in an infinite loop. To escape this loop, press Ctrl and C a few times, and now we are back in the interpreter. Another way to use while loops is by entering an expression which always evaluates as true, in order to make Python do something over and over again until you tell it to quit. A great example would be an interactive menu, where a user can select a value and enter a submenu, then return to the main menu, and so on. A frequent way to do this is simply by using while true, which takes care of the condition in the while loop, assuring it is always true. So this is the syntax: while true, colon, and then, I don't know, do something. Okay. We will see such an example after we'll discuss the break and continue statements. Now, one last thing on while loops is that we can use the else statement again, this time with a different meaning than before. The indented code below the else statement will be executed when the condition specified in the while statement becomes false. Let's see an example. So x equals 1, while x is less than or equal to 10. Let's say print x. X plus equals 1. Now the else statement. Else, a colon, print. Let's print out of the while loop. X is now greater than 10. Okay, so let's execute it. So using the same example as earlier, Python prints out x on the screen as long as it is less than or equal to 10. Then when x becomes 11 and the condition becomes false, the code below else is executed. Pretty cool, I think, and very useful too. Now, many times you will see for loops within other for loops. Same thing with if and while statements. You will also have to use if statements inside for loops or while loops, depending on what you are trying to achieve. Next, we're going to have a look at this kind of structures, which are called nested structures. You can use nesting with control flow statements like if, for, and while for a more specific behavior of your Python program. This means using an if inside another if, a for inside another for, and a while inside another while loop. Let's use some basic examples to see what I mean. First, let's refer to the if statements. When nesting an if statement inside another if statement, we are actually telling Python that the indented code below the nested if should execute only if both statements are evaluated to true. So, let's say x equals the string Cisco. Okay. Now if I in x, then if len of x is greater than 3, let's print x and len of x. Okay, this is actually the same thing as the following. If, and let me use some parentheses for better readability, I in x and another pair of parentheses, len of x is greater than 3, colon, print x and len of x. Okay, in this case, just remember that the parentheses are there for a better view of the code. You can use them or not. I recommend using them whenever you feel the need to. Another thing to be careful about is indentation. When using nested structures, there are multiple levels of indentation created. So the second if statement is one level indented from the first one. Then the code which should run after evaluating the second if statement is again indented. So notice the indentation right here. So the print x and len of x statement is 2 levels away from the first if statement and 1 level of indentation away from the second if statement. This way, we can easily use indentation as a delimiter between nested structures. This also applies to nested for and while loops. So keep in mind that each level of indentation changes the logic of the program. Anyway, it is recommended that you keep a low level of nesting to have a clear and readable program. So 2-level nesting, like in our example, should be just fine. Now let's look at nested for loops. Let's assume we have two lists and we want to multiply each element of the first list by each element of the second list. For this, we should iterate over both lists at the same time, taking each element into account, then do the multiplications and return the results. So let's say we have list 1 equals 4, 5, and 6, and list 2 is 10, 20, and 30. Now let's see the nested for loops. For I in list 1, now the nested for loop for j in list 2, the second level of indentation, and now print I times j. So what this code tells us is, dear Python, for the first element in list 1, take each element in list 2 and multiply them. Then for the next element in list 1, take each element in list 2 and multiply them as well, and so on until list 1 is exhausted. You can go back from the second indentation level to the previous one just by hitting tab once instead of twice, so that the new code is vertically aligned with the second for loop, so at this level of indentation right here. Let's see this. Let's say that after doing the multiplications we did for each element of list 1, we want to also print that element of list 1, just to have it printed out for each iteration. We can go back one indentation level and just type print I at the same level of indentation with the second for loop. So let me show you. For I in list 1, for j in list 2, print I times j. And now, getting back at the first level of indentation, print I. This is the result. Notice that we have the elements of list 1 somewhere in between the results of the multiplication. So 4, 5, and 6. Okay. Using a for loop inside another for loop can be pretty useful sometimes. Now let's look at while loops and consider the same example from the while loops lecture. So let's say we have x equals 1 while x is less than or equal to 10. Let's say print x, and x equals x plus 1. So this returns all the numbers starting from 1 up to and including 10. Now let's see a nested while loop. So let me write this first. X equals 1 while x is less than or equal to 10. Let's say z equals 5. X equals x plus 1. Now the nested while loop while z is less than or equal to 10. Print z, and z equals z plus 1. So notice that we have 5, 6, 7, 8, 9, and 10 printed out 10 times. Now let's see the code. The first while loop does the same thing. It checks whether x is less than 10 or equal to 10. And as long as this condition is true, it increments x, and the new thing here, runs the second while loop each time the first loop is executed. Now the second while loop does the same thing as the first. It takes the value of z, compares it with 10, then increments it by 1, and it does this as long as z is less than or equal to 10. So the final result is made of the result of the second loop, which is 5, 6, 7, 8, 9, and 10, printed out 10 times due to the first while loop. This is just a basic example of nesting while loops. The next thing I'll add here is nesting a structure inside a different structure. Let's try nesting an if statement inside a for loop. So let's try for number in range of 10 if 5 is less than or equal to number, and this is less than or equal to 9. Then print number. Here the for loop iterates over the list created by the range of 10 function, so numbers 0 through 9, Then the if statement specifies a condition before printing the numbers. Actually, there are two conditions. The number should be greater than 5. This is the first part of the condition. And also, it should be less than or equal to 9. This is the second part of the condition, in order to execute the indented code below the if statement. Okay, I think now you have a very good understanding of nesting and indentation, so it's time to move on to the next lecture. The break and continue statements are used to handle the flow of a while or a for loop in a Python program, meaning the programmer can interrupt or restart the execution of a loop structure in certain conditions. Let's start with the break statement, which is used to terminate the loop in which it resides. To show how break works, we will first write a loop. So, for number in range of 10, colon, if number equals 7, and now let's use the break statement inside this if block, and the print number outside the if block. So, print number. Okay, what this loop does is it takes each number in the list generated by the range function, so it starts from 0, and compares it to 7, according to the if statement. Since the numbers 0 to 6 do not meet the condition in the if statement, the break statement is not executed for any of them. So Python goes further and prints them, as we can see. When 7 is selected from the list, it is then passed to the if statement, and the condition is evaluated as true. This is where Python goes and executes the indented code below if, where it finds the break statement, which tells it something like this. Stop the execution here, ignore the print statement below, and completely quit this for loop. Because Python completely exits the for loop, the rest of the numbers in the list, meaning 8 and 9, are also ignored, and the Python program keeps executing other code below the for statement, if any. Now what if we have a for loop nested inside another for loop, something like in the previous lecture? Let's first define list1 and list2 again. So we have list1 equals 4, 5, 6, and list2 equals 10, 20, and 30. Now let's write the loop for I in list1, then a nested for loop for j in list2. Inside this nested for loop, we'll have an if statement if j equals 20, then break. Outside the if block, we will keep the print I times j, and then let's say print outside the nested loop. This final print statement will be included actually in the first for loop. Okay, let's run this code. So as we saw in the previous lecture, in this case, Python takes the first element of list1 and tries to multiply it with each element of list2. Then takes the second element of list1 and tries to multiply it with each element of list2, and so on. But in this case, we have the if statement inside the nested for loop and the break statement within this if block. So each time Python tries to multiply the elements of list1 with 20, the second element of list2, the break statement tells it to stop the execution and quit this loop. Remember that the break statement terminates only the execution of the innermost loop, not all loops. So keep this in mind. That's why each time the break statement interrupts the multiplication process, we still receive the outside the nested loop string, because the print outside the nested loop statement is not part of the nested loop itself. Instead, it is part of the outermost loop. One more thing, notice the indentation here. For j in list2 and print outside the nested loop are at the same level of indentation, so keep an eye on this. Now the same principles apply with while loops. We won't get into while loops in this case, just to avoid getting boring. Now let's have a look at the continue statement. When Python finds a continue statement inside a for or a while loop, it ignores the rest of the code below for the current iteration only, then goes up to the top of the loop and starts the next iteration. In order to see this in practice, let's consider the same lists and for loops as earlier, but replace break with continue in our code. So, we still have list 1 in memory, also list 2. Okay. Now using the up arrow key, let's enter for I in list 1, for j in list 2. Now let's find the if statement, if j equals 20. Now instead of break, let's type in continue, so continue. Okay. We will use the same print, I times j, and the same print outside the nested loop at the first level of indentation. Okay, let's run this code. So let's study the result of this code to understand what happened. Python did the same thing here. It took the first element of list 1 and tried to multiply it with the first element of list 2 and succeeded. So we got 40 as a result. Then Python tried to multiply 4 with 20. But since 20 satisfies the condition in the if statement, the program executes the continue statement, which actually ignores the rest of the code in this loop, and that's why we won't see 80 as a result. After ignoring the multiplication below continue, Python goes to the top of the nested loop and extracts the next element from list 2, which is 30, and that's why we see 120 in the result. Finally, after list 2 is exhausted, Python goes and executes the print outside the nested loop statement, which is part of the outermost for loop, so it isn't affected by the continue statement. Then the program repeats the same steps for the next two elements of list 1. As with break, the same principles apply to while loops when speaking about the continue statement. Finally, let's talk about the pass statement. Pass is the equivalent of do nothing. It is actually a placeholder when you just want to write a piece of code that you will treat later, but you don't want to forget to add it into your code. So let's see a short example of this. Let's say for I in range of 10, colon, and then just type in pass. So this code does nothing, as I said, but what if you just don't write anything below the for statement? What if you just skip the pass statement? Let's see it. Let's use the same for I in range 10 and just type nothing. So we got an indentation error, expected unindented block. Python throws an error because the code is invalid if you don't type anything inside the for loop. This is the reason we need the pass statement. Okay, I think we covered enough in this lecture, so let's go further to exceptions. In Python, you may encounter two main kinds of errors: syntax errors and exceptions. A syntax error occurs when you don't follow Python's syntax and maybe forget a colon or the indentation is not proper. Let's try this in the interpreter. First, let's not put a colon after a for statement and see what Python does. So let's try for I in range of 10, and just type on enter. So we get a syntax error as expected. This is an example of an error. Now let's try to enter an empty block of code using the same for loop as we did in the previous lecture. So for I in range 10, colon, and an empty block. Notice that in this case, Python sees that you have no code indented below the for statement, and you didn't even use the pass statement as a placeholder, so it throws an indentation error, telling us that it was expecting an indented block and we didn't provide one. Now let's talk about exceptions. Unlike regular errors, exceptions are raised during the execution of the program, interrupting the normal flow of the application code. Let's see a couple of examples. First, let's use the same for loop to generate one of the many types of exceptions. So this time I will misspell the name of the range function and wait for Python to notice my mistake. So let's say for I in RNGE of 10, let's say print I. Okay, so what do we have here? A name error. This means I misspelled a word in my code. In this case, a function name. This time I forgot to type an A in the range function. Okay, another type of exception is raised when trying to divide a number by 0. Let's see this in the Python interpreter. So let's say for I in range of 10, this time spelled correctly, print I divided by 0. Okay, fair enough, we cannot divide a number by 0, so Python raises a special exception for this. Notice that Python helps us localize the cause of the exception by also displaying the line of the code that generated it. So in our case it is line 2, the one containing print I divided by 0. There are many types of exceptions in Python. We won't analyze all of them now because you will most likely encounter them as you start creating real programs. Okay, this has been a general introduction to exceptions in Python. In the next lecture, we are going to see how to handle exceptions in the code we write. Okay, we've seen some Python exceptions and how they look like, but given the fact that an exception interrupts the normal execution of Python code, it would be more convenient for us to handle an exception when it occurs and tell Python to keep executing the rest of the lines of code in the program. To do this, we will use the so-called try-except block for exception handling. Let's consider the zero division exception from the previous lecture and see how can we handle it properly. First, let's define the try and except clauses. In the try clause, you insert the code that you think might generate an exception at a given point. Of course, this code will have one level of indentation from the try statement itself. As with for or while or if statements, you must always type a colon after the try keyword. Then you have to input the piece of code you want to execute. So let's do this inside the Python interpreter. We will use the same old for loop from the previous examples. So for I in range of 10, colon. Then at the first level of indentation, try, colon. Enter. Then at the second level of indentation, let's try print I divided by 0. Okay, up to this point, you should notice a couple of things. First, as I said, the indentation. The try statement is indented by one level to the right from the for statement. After try, a colon should always be inserted. Then the code we want to check for exceptions will be also indented one level from the try statement level to tell Python that the following code belongs to the try block. In this case, we are 100% positive we are going to get an exception. Now let's move to the second part, the except block. Below except, we will specify what exception types Python should expect as a consequence of running the code inside the try block. You should think of this whole try except procedure as you are telling Python the following. Try to execute the indented code below. If no exceptions occur while executing it, then skip the except block and move on to the rest of the program. If an exception does occur and it is defined in the except statement, then execute the indented code below that except statement. So, in our case, knowing that division by 0 is not allowed, we are expecting a zero division exception. Now let's tell Python what it should expect. So, for I in range 10, try to print I divided by 0. Now at the same level of indentation with try, we type except and, the name of the exception we are expecting. So let's say zero division error. Then a colon and one level of indentation to the right. Let's say print division by 0 is not allowed. And that's it. Okay, so let's analyze the result. Python took each element from the list generated by the range function, tried to divide it by 0 inside the try block, realized that this isn't possible, so it raised the zero division exception in the background. Now, because we had that exact exception defined and treated by the except clause, it didn't generate the same old output like we had up here, but instead it executed the code within the except block. If we would not have the zero division exception specified in the except clause, or if we would have any other exception defined instead, Python would give us the classic exception output like we saw in the previous try. Now let's test this. Let's say that we didn't realize that a zero division exception may be generated by our code, but instead we wanted to cover any name exception which could have occurred. So we defined this in the except clause. Let's use the up arrow key for I in range 10. Try to print I divided by 0. Then except, and instead of zero division error, let's say we have name error. Enter, and let's say print you have a name error. As you can see, this time Python returned the old exception output. Another thing I want to clarify is that if the code inside the try block does not generate any exceptions, then Python doesn't even look at the except clause and moves on to the rest of the program if you indeed have further lines of code in your program. To do this, I am going to change the denominator in division operation to be 1 in order for the operation to be allowed. So, for I in range 10, try, print I divided this time by 1. Let's use the old except zero division error. Now let's print something here. Let's say zero division is just wrong. And then a print statement at the same level of indentation with the try and except blocks. Print, let's say, the rest of the code. Okay, I have also added the print the rest of the code statement in the for loop at the same level with the try and except blocks, just to show you that for each iteration, Python tries to execute the I divided by 1 operation. It succeeds without any exceptions, skips the except block, and then executes the rest of the code without even caring that except is there. Pretty rude, but that is the way Python does it. Another thing to add here is that you can have multiple except clauses after a try block. This enables you to be super cautious and handle multiple types of exceptions that can be raised by the try block. So let's see this. Let's use for I in range 10, try. Let's use print I divided by 1. And now let's define multiple exceptions. So except, let's say, zero division error. Here we will print not allowed. Okay, let's try to catch other exceptions as well, except name error. Print you have a name error. Let's also add another one. Let's say except value error. This is another kind of exception in Python. Let's print wrong value or something like this. Okay, now you may ask me, okay, but what if I want to catch all possible exceptions that can be generated by my code inside the try block? Well, you can just use the except clause alone without specifying an exception name to be expected. Something like this. Let's say try, print I divided by 0, except, and that's it, colon, and let's say print exception was raised. Okay, this is however not recommended, and it is not a good practice because it will catch absolutely all programming exceptions which may occur and hide the actual root cause of an exception. I strongly recommend that you create multiple except clauses if you need them and specify the exception name each time. Finally, two more things about try except blocks. You can add two other clauses after the except clause or clauses. They are called else and finally. The code inside an else clause is executed if the code inside the try block raises no exceptions. So let's try this. Let's say try print 4 divided by 2 except name error. Sorry, let's type this again. So try print, okay, except name error, print name error. Okay, now let's insert an else clause. So else colon, let's say print no exceptions raised by the try block. Now the code inside a finally clause is executed whether the code inside the try block raises an exception or not. So anything you type inside the finally clause will be executed regardless of an error or exception was raised or not. So let's try this. Try colon print 4 divided by 2. Let's say except 0 division error print not allowed. Okay. And now let's add the finally clause. So finally, then a colon, and then print, let's say, I don't care if an exception was raised or not. Okay, so as expected, we got the code executed by the try block and the print statement executed, the print inside the finally clause, which, as I said, is executed no matter if any exceptions were raised. Now, using code that will generate an exception in the try block, let's try this also. So let's use try, print, this time print 4 divided by 0, the except clause, and finally the finally clause. So finally, I don't care if an exception was raised or not. Okay, as expected, we got the print statement executed inside the except block, not allowed because we indeed had a division by 0 this time. And in the end, the finally clause was also executed because it doesn't care if an exception is raised or not. Okay, that's almost all you need to know about exceptions and exception handling for your future networking tasks. Big topic ahead, functions. This is a core topic in Python and in fact in any other programming language. We are going to use functions a lot to build our applications. So, first, what is a function? Well, you can use a function to organize your code in blocks that can be later reused. This is helpful if you want better readability for your code, modularity, and also time saving when running the code. This is going to be more obvious for you when we will start using functions and see some examples. Before starting to write code, remember that functions follow the same syntax rules as other structures we've seen so far, but also add some features that we're going to see soon. First, a function is defined using the def keyword, followed by the name of the function, a pair of parentheses, which may or may not contain any parameters, and then a colon. After the colon, on the next row, you will type in the code you want to store in this function, indented by one level, of course, as you have seen we did with if or while statements. Let's see this in the Python interpreter. So let me type this first, def my first function, open and close parentheses. This is our first function. And also let's add a print hello Python. Okay, so as I said before, we have the def keyword, the function name, then the parentheses, and finally the colon. This is the way in which you define functions. One important thing to add here is that in between the parentheses, you can specify the arguments or parameters for a function. We will see how to do that in a moment. Until then, let's further study our function definition. After the colon, which signals the start of an indented code block, we type in the code we want this function to execute, indented, of course. Notice that on the first row inside the function, I typed in a string. This is called a docstring, and its role is to describe the role of the function. But it is entirely optional. Maybe you can use it when you define complex functions within complex applications. However, it is still a good practice to use a docstring inside your functions. Okay, you can access the docstring of a function by using a command that we talked about in section 1 of the course, the help command. Let's see this. So let's do a help on my first function. Okay, we can see this is our first function right here. we basically created the help section for this function by using a docstring. Okay, type Q to quit the screen. Now inside the function, all the syntax rules of Python apply as we saw up to this point. If you have a for or a while loop or an if statement, or if you use dictionaries or list indexing and slicing, the exact same syntax rules apply inside function blocks. I said earlier that functions are reusable blocks of code. Let's see why. After defining a function, with or without any arguments inside the parentheses, we can call that function whenever we need to run the code inside it. To call a function, you just need to type that function's name, followed by the parentheses, and that's it. Let's see this in action. So, my first function, open and close parentheses. Okay, each time we call that function, it executes the code within it. Of course, this is a very basic example, but it should give you the main idea about functions. Another advantage of functions is that you can change the code within a function and see the results the next time you call the function. So we can say they are dynamic structures. So let's modify our structure, our function. This time let's print hello Java, and now let's call the function. Okay, as you can see, the function has been indeed updated. Okay, now let's talk a bit about parameters and arguments, and we will expand on that in the next lecture to see multiple types of arguments that can be passed into a function call. For now, let's change our function and insert our first parameter into the picture. Remember, parameters are written inside the parentheses. Let's see how they work. Let's use def of my first function of x, let's say, and let's just print x. So in this case, x is passed as a parameter to our function and then used into the code. This means that when we are calling the function and give it an argument of our choice, that argument will be passed to the code inside the function. Let's see this. Let's try my first function of hello Python. Okay, nice. So we called our function and told Python to use the string inside the parentheses as an argument. Then the string is passed to the print statement and thus returned to our screen. You can also enter multiple parameters within a function definition, like this. Let's say my first function of x and y, and let's print hello, plus x, so string concatenation, and print hello plus y. So according to this piece of code, we expect that when calling the function and passing two strings as arguments inside the parentheses, they will both be printed out to the screen, preceded by the hello string. So let's see if we are right. Let's call my first function and use Python as the first string and Java as the second string. Okay, notice that x was mapped to Python and y was mapped to Java, because that was the order in which we passed the arguments. Pretty intuitive, I think. Okay, as a side note, one thing to remember here is the terminology when using functions. Parameters are the ones written in parentheses when calling the function. So let's say in our case x and y. Arguments are the ones written in parentheses when calling the function. So in our case, Python and Java. Many times they are used interchangeable, but you should try to follow this terminology though. We will discuss arguments in more detail in the following lecture. Now we are going to touch another topic, that is the return statement. This statement is used to exit a function and return something when the function is called. So let's delete the print statements inside our function and see how does the return statement work. Let's actually redefine our function. So def my function of x and y. Let's type in, let's create a variable sum equals x plus y. Okay, and that's it. So we created a variable inside our function in which we will store the result of adding x and y, which are the function's parameters. Let's see if our function returns something when we call it. So let's try my first function let's use some integers, let's say 1 and 2. So nothing is returned. That's because we didn't specify what do we want to get back from the function. This function just creates the sum variable and stores the result of adding 1 and 2. But it doesn't return anything. That's why we need the return statement. Let's see how to use it. Let's get back to the function. Sum equals x plus y. And let's type in return. This is the keyword. And the variable we want to be returned. So sum. Now let's call the function again using the same arguments 1 and 2. This time we got a result. This time we told Python to return the value stored in the sum variable, and we got the expected result of adding the two numbers. Now we can just change the function and call it with any desired argument. So let's say 2 and 2, let's say 2 and 20. Okay, now let's add another parameter, change the math expression and return the sum value, this time squared. So let's get back to the function. Let's say sum equals x plus y times z, and let's return sum to the power of 2. Okay, let's call the function now. Let's use 1, 2, and 3. Okay, oh, I forgot to add another parameter in the function definition. This happens, don't worry. So x, y, and z. Okay, use the up arrow key. Return sum to the power of 2. Okay, now let's call the function. Okay, and it returns 81 as a result. The result seems correct, so that's great. The last thing I should add here is that if you just use return without specifying what do you want to be returned, Python will give you back the none value. So return without specifying what to return is actually the same thing as return none. So let's test this. Let's use the same function. Let's write it again just to have it here. Okay, return, and instead of sum to the power of 2, let's return and type nothing more. Now let's call the function again with the same arguments. So you see nothing is returned. Good, this is what we wanted in the first place. Next, we will cover function arguments. Okay, we've seen how to use function arguments. We went through some examples. But why do we need a special lecture dedicated to arguments? Well, that's because we've only seen one type of function arguments, but Python defines several types, and we're going to see each of them in this lecture. The type of arguments we've seen in the previous lecture is called positional, meaning that the number and position of arguments in the function call should be the same as in the function definition. If the number of arguments is different, then Python will return a type error. Let's test this. So we had my first function of x, y, and z. Let's define it again. So def my first function of x, y, and z. Okay, colon. Sum equals x plus y times z, and return sum. Okay, this function takes three arguments, x, y, and z. But if we specify only two of them when calling the function, Python will tell us that the number of arguments it was expecting and the number of arguments we gave do not match. So let's say this. Let's say my first function of 1 and 2. Okay, so we got a type error. My first function takes exactly 3 arguments and 2 were given. Also remember that in this case, the order of arguments is very important when calling the function, because the first value in the function call will be associated with x, the second value with y, and the third value with z. Now let's see another type of arguments, keyword arguments. Keyword arguments allow us to ignore the order in which we enter the parameters in the function definition, or even to skip some of them when calling the function. Let's see this in an example, using the same function as earlier. So let's refer to the same function, my first function. Using keyword arguments means you can specify the parameter name and assign it a value inside the function call. So let's see this. My first function of, let's say, x equals 1, comma, y equals 2, and z equals 3. And we got the result 9, which is correct. This allows us to type them in a different order as well, unlike positional arguments. So let's try this. Let's say z equals 3, x equals 1, and y equals 2. So notice we get the same result, 9. Okay. You can also mix positional and keyword arguments, but the rule when doing this is to first specify the positional arguments and then the keyword arguments. If you don't follow this rule, Python will return a syntax error. So let's see this. My first function, let's say x equals 1, y equals 2, and let's say 3. As I said, notice the syntax error, non-keyword arguments after keyword arguments. Now let's try this in the right way. So let's say 1 and 2 and z equals 3, and we got the same result. Correct. This way we can call the function multiple times, having z equal to 3 each time and only changing x and y. You can also define a default value for an argument by specifying it in the function definition, so in the parameters list. Let's see this. So def my first function, and we have x, y, and z equals 3. Sum equals x plus y times z, and the return statement, return sum. In this case, the value of 3 is assigned to z by default, in case no other value is specified in the function call. If another value for z is specified when calling the function, then the new value overrides the default one. So let's test this. Let's say we have my first function of 1 and 2. Okay, so we got 9 because z was by default equal to 3. However, if in a function call we do want z to take another value, we can explicitly specify this. So let's say my first function of 1, 2, and 4. This time we got a different result, 12, because now z is equal to 4. But what if you need to define a variable number of parameters in a function definition, and you don't know how many parameters you need? Well, Python has a solution for this as well. In fact, two solutions, one for positional arguments and one for keyword arguments. Let's see them. The solution to pass a variable length parameter list is to use an asterisk, like this. Def my first function of, let's say, x, and an asterisk, and args, colon, print x, let's say. The args variable you see here is actually a tuple of possible additional parameters. The tuple is initially empty if we don't specify additional parameters apart from x. So calling this function with a single argument would be a valid thing to do because x takes care of this. So let's try my first function of, let's say, the string first. Okay, and first is printed out. In fact, to see this better, let's add a print statement inside the function to also see the contents of the args variable. So let's redefine the function. Okay, print x, and also print args. Now let's call the function again by passing a single argument. Okay, now when calling the function, we can see x has been printed out. This is the string. But we also got an empty tuple, which is actually the args parameter. Now let's call the same function, but with more arguments this time, and see if the tuple gets populated. So, my first function, let's add a couple of strings, second, third. Okay, so we have the confirmation that the args variable is indeed a tuple. But how can we print all the arguments we pass into the function? Well, simply by iterating over that tuple using a for loop. So let's remove the print args statement and write the for loop. The def statement, print x. Now, let's say for each parameter in args, colon, print each parameter. Sorry. Also, don't forget about correctly indenting your code when using the for loop. So, this is the function. Now let's call the function again with 3 arguments. Okay, we got the expected result, right? Now, if you have or need a variable number of parameters but want to use keyword arguments instead of positional arguments when calling the function, you can use a double asterisk followed by kwargs, so something like this. The concept and functionality is similar, so I won't get into it just to avoid getting boring. Remember that the names args and kwargs are just conventions. You can use any name instead, as long as you don't forget the asterisk for positional arguments or double asterisk for keyword arguments. These are mandatory. You can find a guide to use different type of arguments in the link attached to this lecture. What is a namespace in Python? Well, as its name implies, a namespace is a space holding some names. What names are we talking about? By names, I am referring to variables, functions, or classes we create. Now, you can think of a namespace as a container holding the names we define, where each name is associated with the namespace in which it is defined. This way, you may have the same name defined in different namespaces, and we will see this in practice in a second. The last thing I should mention before we get to work is that there are three types of names, depending on the namespace in which they are defined or held. The built-in namespace contains the built-in functions. We've seen a lot of built-in functions until now. For example, we have the len function, or range, or max, and so on. They are available whenever you want to use them, whether you are trying to access them from the Python interpreter shell or into a Python script. The global namespace contains all the variables or functions you define or import directly into your program, whereas the local namespace refers to the names you use only inside a particular function, for example. Let's better see this by creating a Python file and playing around with some variables. Let's create new file.py. Okay. By the way, you should open another terminal shell. I think this will make your life a lot easier because we are going to edit the file in the first terminal and then run the file in the second. Now, let's get into the file. New file. I for insert. And let's use a name from the built-in namespace, just to prove that it is already available to you. So, print range of 10. Let's save it. And now let's run the file. Okay, so the file was successfully executed, and let's see the file. Notice that we didn't need to define the range function prior to using it because it is a built-in function and it belongs to the built-in namespace. Now let's get back into the file and try to use a non-built-in name. Okay, I for insert, let's delete the range of 10 and let's say print myvar and save the file. Now let's run it. Okay, as soon as we run it, we get an error saying that the name myvar is not defined. This is because myvar is neither part of the built-in namespace nor defined within the file, so Python doesn't know where to get it when trying to print its value. Now let's get back into the file and create the variable by assigning it a value. So let's say myvar equals 10. Let's save it and run it. This time the file is successfully executed because myvar was defined. Let's see the file. Myvar was defined before the print statement. We can say that we created myvar in the global namespace of our program. So now myvar is a global variable. Now let's change the file and move both statements inside a function, and then call that function in order to have the value printed out, like in the previous example. So let's define def myvarfunc without any parameters. And let's indent both statements to make them part of the function. So, okay, also let's call the function. So my var func. And let's also add another print statement to print the value of my var times 10. Okay, so let's save the file. Let's see it. And now let's run it. Okay, so let's analyze the result. First, we got 10 printed out. That's because inside the function, we first created my var and then used it in the print statement. We then called the function, and that's how we got 10 on the screen. But wait, shouldn't the final print statement return the value of 10 times 10, so 100? Why did we get an error saying that the name myvar is not defined? It's right there in the function, isn't it? Well, here's the catch. This time, myvar is not a global variable, which is available to use across the entire program. This time, myvar is a local variable belonging to the local namespace of that particular function. So inside function myvar_func, the variable myvar is okay to use. It is accessible and usable. But as soon as you go outside the function, myvar is no longer available. To better see this, let's edit the file again, this time creating a variable outside the function. Sorry, let's go over here. We will now insert myvar equals, let's say, 20 outside our myvar function and anywhere before the print myvar times 10 statement. Okay, let's save the file and let's run the file. This time we got the same value 10 as before by calling the function over here, and then the value 200 by printing the global variable myvar. Let's see the updated file. Okay, so by printing the global variable myvar equals 20 times 10. Makes sense, right? This example clearly separates the concepts of global namespace and local namespace. Now continuing with the same example, let's delete the final print statement first. So let's go ahead and delete this. Okay, let's also delete this. And let's switch the two statements inside the function. So instead of having my var equals 10 over here, we will insert it somewhere over here. So my var equals 10. And also outside the function, we will define my var again equals 20. Okay, I think this should do it. Let's save it. And now let's run the file. Okay, this time we got a different error, saying that the local variable myvar was referenced before assignment. That's because Python reads the code lines in order. So if you first use the myvar variable in a statement, let's see the file again. So if you first use the variable in a statement and then create that variable, Python will be unaware that you created it when it tries to execute that statement. So when you call the function over here, Python will return the unbound local error. So this is why you should be careful when you create variables and when you decide to reference them. This rule is valid both in the global and in the local namespaces. Now let me show you how to use a global variable inside the local namespace of a function. By keeping this code as it is, we will get the same error each time we run the file. But what if you decide to use the global myvar variable inside the function? To do that, you need to use the global keyword to, let's say, import a global variable to a local namespace. So this is how you can do it. Inside the function, let me edit the file one more time. I for insert. So inside the function, before any other statement that refers to the global variable you want to use, You just type global and the name of the global variable you want to import, so myvar. Now let's run the file. Okay, you can see that now we have the global variable. Let's see the file one more time. We have the global variable used in the print statement inside the function, inside print myvar. Okay, the last thing I'll show you here is how can you use the return statements in our case. First, remember that return is used to exit a function and return something when the function is called. Let's edit our file again and return to the code from the beginning of this lecture when we got the name myvar is not defined error. So let's edit this. Okay, let's delete the global statement. Let's delete the myvar definition. Okay, and we had here print myvar times 10. Okay, so I think this was the code. No, one more thing. We had myvar defined before the print statement. So let's modify this too. So myvar equals 10. Okay, I think this should do it. Now let's add a return myvar statement at the end of the function and then run the file. So return my underscore var. Let's save the file and now let's run it. Notice that we still get the 10 returned by the function call over here. Let's see the file. Okay, so we still got the 10 from myvar_func over here. But we are unable to use the myvar variable further into the program in order to have that variable available outside the function. Now you can make use of the return statement we defined and store the value returned by the function in a new variable outside the function. Then you can use the new variable in the final print statement. Let me show you what I mean. So let's get into the file and assign my new var equals myvar_func. Okay, and also replace my var with my new var. Okay, let's save it and run it. Okay, now we get the 10 from the print statement inside the function and from the function call itself, and then 100 from the print statement at the end of the file. And this is what we wanted in the first place. So this is the way you can propagate a variable from the global namespace to the local namespace. Cool. Now it's time to learn about modules and ways of importing them. A module is actually just a Python file containing Python functions, variables, or classes. Of course, these functions and other data types inside a module are not randomly grouped inside that file. They are grouped together to provide some functionality which can then be used further inside other programs. Modules are also a great way to logically organize your code. There are a lot of Python modules you can use into your programs. Some are built-in, remember the sys module, and some can be downloaded, unzipped, and installed, like the ones you can find in the Python modules directory on this virtual machine. You can also create your own modules, meaning you can write some code into a file and then use that code in the application you are building by simply importing the file. Now let's consider the math module, which is a Python built-in module, and see its contents in the Python interpreter shell. So let's go in the shell. And first let's import math and then do a dir on math to see its contents. We can see here a list of names which are specific to this particular module and exist within its own namespace. Now remember the way we used the argv function from the sys module? After importing the module, we typed the module name, so sys, then a dot, and then the function name, argv. This is the general rule for accessing module functions and variables when using the import statement. Now we can do the same with the math module. So let's access the value of pi. So math.pi. Okay, so this is the pi number used in math. Nice. If you forget to import the module you need and try to access one of its variables or functions, you will get a name error saying that the name math is not defined. Now let's create our own module and see the three ways in which you can import data from a module. First, let's exit the interpreter. We are currently in the working directory. Let's create two files here. So touch my module.py and python app.py. Let's consider mymodule.py as being our user-defined module and python app.py as being an application we are working on. Let's open each file in a separate terminal so we can see this better. So vim mymodule, and over here let's do a vim python app.py. Okay. In our python app.py file, we are going to enter just a print statement. This will be a very basic Python application. So let's say I for insert, print, this is my app. Okay. Let's save it and run it. So Python. Okay. Now let's also enter some code inside our module. We will define a variable, a function, and a print statement here. So let's go over here, I for insert. Let's say my var equals 10. Let's define the function. So def my function without any parameters. Inside the function, let's enter a print statement. So print, this is the function inside the module. Okay, and then another print statement outside the function, print, let's say this will be executed. As you can see, the myvar variable is not used anywhere in the module, and the function is not called anywhere either. They are available there for you to import and use them into your program. Let's save the module now and see how can we use the code inside the module into our own application. As we've seen so far, we can use the import statement in order to use the code inside the module. An important thing to remember here is that when you import a module into your program, Python will execute the code inside that module. This will happen only once, no matter how many times you import that module. So let's test this by importing my module into python app.py. So import my module. Both files are in the same directory, so the module is automatically found by our application. When importing a module, you should skip the .py extension, so just import my module. Let's save this and run it. Okay, as I said, when first importing a module, the code within that module is executed. So now we got back the string printed by the module and then the string printed by our application. Cool. Now to prove that the code in the module is executed just once, let's say that for some reason you import that module twice into your application. So let's go ahead and enter another import statement into our python app.py file. So let's say import my module. This is a very basic test. This is not something very used in practice. Okay. Now let's run the app again. So here we have the proof, the string printed by the module. Let's also see the code inside the module. So the print statement inside the module is executed just once, even though we have imported the module twice. So this will be executed, is displayed only once when running the app. Okay, nice. Another thing to add here is that now you have all the variables and functions inside my module available into your program's namespace. You can reference them and use them by typing the module name, a dot, and then the variable or function name. So let's test this. Let's go into the file. Let's go ahead and delete one of the import statements. Okay. Now let's go ahead and print my module dot myvar, and also let's call the function within the module. So let's say my module dot, and now the function name, so my function. Okay, let's go ahead and save this, then run it. Okay, as you can see, both the value of my var and the print statement inside the function were executed when running the python app.py file, because we referenced them correctly into this file. Cool. Now this was the first way of importing code from an external source, a module. Let's see the second way. You can use the from import statement to import only some variables or functions from a module into your application's namespace, thus reducing the resource usage of your program. Okay, let's say that from my module you only need to use the myvar variable into your application. You can do this in the following way. Let's go into the file and replace the import statement with, sorry, I keep forgetting, I for insert. Okay, so from my module import, and we said that we need only the myvar variable, so import myvar. Okay, let's go ahead and delete this, and also let's delete the reference to the module. Now let's run our app one more time. This time we got the string printed by the module, because Python executed the code inside the module, so we got this will be executed. Then we got the string printed by our application, so this is my app, and then the value of my var, which we have imported. Notice one more thing here. Unlike the first way of importing we've seen earlier, when using the from import method, you are not required to specify the module name before the variable or function name. Let's see the file one more time. So, as you can see, we didn't need to specify my module and a dot before printing my var, so before the my var variable. Using the from import method, you can use any variable or function directly into your program without specifying the module name. So remember this is one advantage of this method. On the other hand, you cannot create another variable with the same name into your application, so you cannot define another myvar in the current namespace of python app.py. The last method of importing is using the from import and a star or an asterisk. Here the star means import all names in that module. This method is generally not recommended because it overloads the local namespace of the application you are importing into. So if you want to import all the names in a module, you should better use the old import statement. Now that we've seen the import methods, let's talk a bit about where you can store and how you can locate a module into your file system. In our example, we had both the module and the application file in the same directory. So if we do an ls on working there, you can see my module and python app.py inside the same directory. Well, Python first checks the current directory to see if the module you are trying to import is stored there. If it isn't in the same directory, Python will look for the module in all directories in the Python path variable, which is actually a list of directories. You can set the Python path variable with the following command. Let's say set Python path equal, and then the path you want to configure. Let's say in user local lib Python 2.7 and so on. Finally, if Python does not find the module until this point, it will search into the default path, which is usually this one over here, user local lib Python 2.7. This is the case for Linux, of course. The last thing we are going to talk about in this lecture is how to skip the execution of some codes when importing a module. In our module file, let's say that we don't want to execute the print statement at the end of the file, so print this will be executed. So we don't want this print statement executed when importing the module into our application. We want to keep it in the module, just not execute it when importing that module. For this, we are going to use a trick in the module. So let's get inside the module. I for insert. We are going to include the code we don't want to be executed at import using an if statement. I will write this and then I will translate it. So, let's get down here. If double underscore name double underscore equals double underscore main double underscore colon, and then the code you want to not be executed when importing the module. Okay, let's save it. Let's see it. Okay, let's go ahead and delete this. Now in our application file, let's return to the old import statement and add the module name as a prefix to my var and my function. So let's just import my module, print my module dot my var, and let's call the function inside the module. So my module dot my underscore function, and let's save the file. Now returning to our module, the if statement can be translated like this. If this file, mymodule.py, is executed as the main program, let's say as a standalone application, go ahead and execute the code below, in addition to the rest of the code in the module. If the file isn't executed as a main program, but instead it is used as a module and imported somewhere else, then don't execute the code below the if statement. So let's test this. Let's execute our application. Notice that the print statement below if in the module is not executed anymore when we import the module. Now let's run the module as a standalone application and see if the print statement gets executed. So Python mymodule.py, and indeed we have the print statement printing the string as expected. This is because this time the file was treated as a main program and not as a module. To find out more about the theory behind this trick, check out the link in the additional resources section of this lecture. For now, just remember the trick itself. You can apply it whenever you build your own modules. Python provides all the tools you need for handling files in your operating system. You can open and read files, you can write or append to a file, and also store and use the information within a file into your application. As you do with any file in your file system, whether it is a Word document, a picture, or a video, you first have to open the file in order to read or modify its contents. For this, Python gives you the open function, which actually creates a file object that can then be used in different ways. You are not required to import any modules to be able to use all the file methods Python provides to the user. So don't worry about importing anything. Let's first create a txt file in the working directory and insert some data into the file. Then start playing around with it. I have already created a file named routers.txt having some networking vendors as its contents. So let's see the file. Okay. Now it's time to create a file object and read it. This is how you can do this. First, you should go into the Python interpreter shell. You should type in a name for the file object you create, let's say my file. Then the equal sign, and then you will use the open function. So open, and in between parentheses, you first specify the name of the file you want to open, enclosed by double quotes. So routers.txt. Then, separated by a comma, you enter the access mode in which you want to open the file, also enclosed by double quotes. So, let's open the file for reading. This means we should use R. Okay. The basic modes in which you can open a file are R for reading. Keep in mind that this is the default mode, so if you don't type in R when opening the file, like we did here, Python will open it for reading, so read only by default. The second mode is W for writing, and the third mode is A for appending to the end of the file. You may also encounter B. This stands for binary format, and it is useful when playing around with binary files like photos, Adobe PDFs, or executable files, and so on. I will provide a complete list of file opening modes somewhere in the next lectures in this section. Now let's check our file object. So, my file. Notice that the object was created in memory at a particular address right here, and that the file was indeed open for reading. Mode R right here. If you want to check the mode in which a file has been opened, you can check out an attribute named mode for your file, like this. You can type in myfile.mode. So again, we see that our file is currently open for reading. Now, having the file open, let's see how to access and see the data within the file. Python provides three important methods to read data from a file. The first method is read, which returns the entire content of a file in the form of a string. So let's use myfile.read. So you see we have all the vendors in a single string, separated by the new line character. Although not very static, this may be useful for searching something in the entire file or maybe matching some text patterns inside the file. We will talk about patterns and regular expressions in the next section. One more thing about the read method is that you can tell Python to read only a number of bytes from the file and return that many characters, not the entire file. You can do this by entering an integer in between parentheses, like this. Let's say you only want Cisco to be returned. This means the first 5 characters. You would type in myfile.read 5. This doesn't return what it should. Did I lie when I said it will return the first 5 characters in the file? Well, no, I didn't. This is where the concept of cursor enters the game. The cursor is the position at which you are currently located inside the file. So after you read the entire file, you are positioned at the end of the file. That's why nothing is returned when you want to read further. You actually have nothing to read anymore. You already scanned all the text in the file. To go back to the beginning of the file, you have to position the cursor before the first character. You can do this with the seek method. So seek, where in between parentheses you enter the position or better said, the number of bytes from the beginning of the file at which you want the cursor to be positioned. If you want to start from the very beginning of the file, you will use seek of 0. So let's use this on our file, myfile.seek of 0. Okay, now we are at the beginning of the file. To see the current position of the cursor, you can use the tell method, like this. myfile.tell. Okay, this shows us that we are positioned at 0 bytes from the beginning of the file. Now we can read the file again. We wanted to read only the first 5 bytes or characters in the file. So let's do this again. myfile.read of 5. Okay, so we got Cisco returned. Nice. Another method is readLine. This method returns the file content line by line each time you use the method. Let's see this in practice. But first, let's go back to the beginning of the file again. So myfile.seek of 0. Okay. Now let's use the readLine method. So myfile.readLine. Sorry. Okay. Let's use it again and again. So we got each line of the file printed out, and then, in the end, we got an empty string. This signals that we reached the end of the file, or EOF as it is called. The third method of reading files is the readLines method. So readLines. Okay. This returns a list where each element is a line in the file. This method is very useful for iterating over a file. So let's see it. Let's go ahead and go to the beginning of the file again. Sorry. myfile.seek. Sorry, seek of 0. Okay. And now let's apply the readLine method. So myfile.readLines. Now you can use a for loop to work with the elements in the list. First, don't forget the seek of 0 methods. If you forget to position the cursor, then you will end up with an empty list when calling the readLines method again. If you do a readLines again, you indeed have an empty list. This is the proof. So myfile.seek of 0 again. Now let's print the vendors whose names start with a capital A. For this, we are going to iterate over the list provided by readLines and use a condition stating that if the list element, which is a string, starts with a capital A, then go ahead and print that element. So for line in myfile.readLines, colon. Then we have the if statement, if line dot starts with a colon and a print line. Okay, notice here that we also got a blank line after each string. That's because we had a \n in each of the list elements. That gets printed too. Now it's time to see how to write and append data to a file. We've seen how to open and read a file. Now it's time to add some data into the file using the w-access method, W for writing. This is used to open a file for writing only. First of all, I should say that the W method also creates the file for writing if the file doesn't exist, and overrides the file if the file already exists. Let me prove this. We will create a file named newfile.txt in the current directory using the open function and the W method. First, in case you don't trust me, let's do an ls on the current directory to see that newfile.txt does not exist. So ls. Okay, we don't have any newfile.txt here. Now let's create the file for writing, and first let's create a file object. So let's name it newfile equals open newfile.txt in between double quotes, a comma, and W for writing. Okay, let's check new file. Now let's check the current directory. Let's do another ls. Good, we have the file where we want it, so over here in the current directory. Also the file, it is already open for writing, so as you can see, mode W. Now let's start writing. For this we have the write method in Python. So let's use new file, our file object name, dot write, and in between parentheses you should enter the string you want to input into the file. So let's say I like Python, a new line, do you, and another new line, and okay, that's it. So, sorry, okay. So we wrote this string to the file. Now let's check that our text was indeed written to the file. You may say, well, let's use the read method for this. Actually, I'm sorry, but you cannot do this, because now we have the file open only for writing, not for writing and reading. But for the sake of the discussion, let's try to read the file. So new file, .read. So we get an IO error saying that the file is not open for reading. I will show you how to open a file for both reading and writing. But for now, let's check if our string was indeed added to the file using the linux cat command. So let's go to the Linux shell, cat new file.txt. Disappointment again. Nothing is shown. Why is that? The answer is because we didn't close the file after writing to it, and thus our change to the file was not saved. Let's go ahead and close the file and then check its content again. We will do this with the close method. We will talk more about closing files in the next lecture, but for now let's use the close method. New file.close, and that's it. Now let's check the file again. Nice, this looks good. So far we used the W access mode inside the open function to create a new file for writing. Now inside the same file, new file.txt, let's add some more data. First we should open the file for writing again, using the open function. Okay. Also don't forget to close the file again after you made all your changes. Let's write another thing. This is a great day for science. Okay, let's close the file. And now let's check the file in the Linux shell. Okay, this looks like this because we didn't add a new line character to the string. Okay, no problem. Let's go ahead and check this as it is. Notice that the old data is not there anymore. So I like Python, do you is not in the file anymore. This is because once you open an existing file for writing, the content of the file is deleted and Python overwrites the old data with the new data you input using the write function. So be very careful when using the open function and the waccess method. If the file already exists, Python will overwrite the old data in the file. Another method you can use to write data to a file is write_lines. This method takes a sequence of strings as an argument and writes those strings to the file. Usually this sequence is a list. Let's use the same file as before, new file.txt. Remember that Python will overwrite the data in the file because we will open the file again for writing. So we open the file. Now let's use the write_lines method, new file.write_lines. And in between parentheses, let's add a list of, I don't know, networking vendors. Let's say Cisco, Juniper, let's use a capital J. Okay. HP. And the last element of the sequence, let's make it a new line character. Okay, let's go ahead and close the file and check the contents again. So Notice that the elements of the list passed as an argument are written to the file without any spaces or new lines in between them. This is how the write_lines method works. You can also pass a tuple to the write_lines method. Let's see this. Let's open the file again, for writing only. And instead of this list, let's use a tuple. A few elements here. Okay, let's say arista. And a \n character at the end of the tuple. Okay, let's close the file. And let's check it again. The new data has been extracted from the tuple and inserted into the file. Good. Now, if you want to keep the data in the file and also write some new data, you should use the access method. This means append. This method adds new data to the end of the file if that file exists. If it doesn't, then it creates the file. So we currently have the via Nortel and arista string inside new file.txt. Let's open the file again, this time for appending, so using the access mode, and let's add a new string. So let's use the write method this time. Let's say this string was appended and a \n at the end. Okay, now let's close the file. Let's check the file again in the Linux shell. And indeed, the old string was kept over here, and the new one has been added to the end of the file right here. I promised that I'll show you how to open a file for both writing and reading at the same time, to be able to read its contents after writing without making use of the Linux shell commands. The access methods to use in this case are r+, w+, and a+. For example, using w+, we'll open a file for writing and reading, and if the file doesn't exist, it will create it. Let's open new file.txt again for writing, using just w, and try to read it. We should get the IO error again, right? So let's say new file, write something, new file.read. Now let's close the file and open it using w+. So new file.close, new file.open, new file.txt, w+, and let's go ahead and write something, the \n. Okay. Let's also jump to the beginning of the file to read properly. So remember new file dot seek of 0. And now let's read the file using new file dot read. Cool, so you can now write and read the file at the same time. Finally, let's close the file to save it and check if the string was written. New file dot close. Let's go to the Linux shell, cat. Okay, so the string was indeed written to the file. Great, now it's time to talk about file closing. After opening a file using the open function, it is always recommended to close that file in order to avoid any issues related to operating system processes. As we've seen so far, Python provides the close method for closing files. After closing a file, you cannot use it anymore for reading or writing. You are required to open the file again to be able to do any of these operations. You can also use a file object attribute to check if a file is closed. Let's see this. We still have the new file.txt from the previous lecture, which is already closed. So let's go in the Python interpreter shell and type in new file dot closed. New file is the file object name we created to open and write to this file. So Python returns true if the file is indeed closed. Otherwise, it returns false. Another way to close a file is using the with statement. This was introduced in Python version 2.5. Using this statement, you don't have to worry about closing the file manually with the close method. Instead, the file is closed automatically. Also, the with method creates a new file object and a new file if you use the waccess method. Let's see how this works. I will write the code and then explain it. So with open python.txt, w for writing, as f, a colon, then an indented block, f.write, let's say hello Python, and the \n. Okay, so first I use the with keyword, followed by the open function, which is used in the same way as before, then the as keyword, and then the file object name, f in our case. The as keyword acts like an assignment operator for the file object. After typing the file object name, I typed a colon, like we did for if statements or functions, and then indented one level from the with statement. You type the code to be executed. In our case, I wanted to write a string to the file, and that's it. Now let's check two things here. First, if the string was written to the file, and second, that the file was automatically closed. So let's go to the Linux terminal and use the cat command. So cat python.txt. Hello Python. Good, the string is there. Now back to the Python interpreter. Let's see f. You see here that f is indeed a closed file. Let's also use the close method. So f.close. Sorry, f.closed. Okay. And this returns true. So the file was indeed closed without us having to do it manually. Keep this method in mind. First, let's try to define a regular expression, or regex as it is usually abbreviated. A regular expression is represented by a special syntax that helps you find and match a pattern inside a string. Let me give you a very basic example. Let's say you have the following string. Okay. Now, what if you want to find the programming language in this string that starts with a capital P and has 4 letters? Or the ones starting with the substring Java, regardless of J being uppercase or lowercase? Or maybe you want the last 4 characters before the 3-digit over here. For all those cases and many more, you will use regular expressions. In this lecture and the next one, we will talk about 4 functions that Python provides for dealing with regular expressions and text pattern matching. Another thing you should know is that all operations related to regular expressions are provided by the re built-in module. So whenever you want to use regular expressions, you should first import this module using import re, and then prepend any function you use with the re and a dot. Now let's start discussing the first function, which is match. The match function searches the pattern you provide as the first argument in the string you enter as the second argument, but only at the beginning of that string. The general syntax for this function is the following. Let's say we type in a equals re.match, and in between parentheses, the first argument is the pattern you want to match, so let's say pattern. Then you have the string in which the matching is done, and then some optional flags. And that's it. A, in this case, is called the match object if the pattern is found in the string. Otherwise, A will be none if the pattern cannot be matched inside the string. Now let's return to our string, mystr, and use the match function to see if the characters y, o, and u are indeed at the beginning of the string. So, we imported the re module. Now, let's do a equals re.match. First, you type in the pattern, in our case, y, o, and u, and then the variable in which the string is stored, so mystr. Okay, let's check A. So you see that A is a match object because Python has found the string given as a pattern, YOU, at the beginning of the mystr string. Now, if you would try to match a random string to the beginning of mystr, you should get back none. So, don't trust me, let's verify this. Let's say ABC. Let's check A. Okay, nothing is returned. Let's do a type on A. So indeed A is of type non-type. Okay, now let's redefine A as it was before, so it would return a match object again. Okay, you can have the entire match returned by using the group method on the match object. So let's see this. Let's do an a.group, open and close parentheses, and we get U. As I said, Python returns the match it found in the string according to the pattern we provided. In this case, the pattern was the string itself, Y, O, and U. Now let me give you an example that uses an optional flag. Let's redefine A and add a flag that tells Python to ignore the case of the matched letters. So let's do an Y, O, and U with the lowercase y on string mystr and re dot capital I. Let's see A. Okay, we have a match object. Let's do an a dot group and we see U returned. Okay, this time we provided the string U in all lowercase, although in mystr we have U written with a capital Y. Let's see. Okay. The match function still returned a valid object because we specified the re.i optional flag for ignore case as the third argument of the function. There are other flags as well. I just wanted to give you an example for now because I find this particular flag very useful. Now, for example, let's say we don't have the string YOU at the beginning of the string. Let's see mystr again. So let's say we don't have YO and U at the beginning of the string. Instead, we have it somewhere in the middle. So let's change mystr. Let's copy and paste this. Okay, let's go over here. Let's delete this and let's say we have U here. Okay. Now let's do the same match as we did before. So we are trying to match YOU at the beginning of string mystr, ignoring the case. Let's see A. Okay, this time nothing is returned. Let's do a type on A. Okay, this time the match function returns none because the pattern we are searching for is not located at the beginning of the string. It is located in the middle of our string. Now, to search for a pattern throughout the entire string, we will use the search function. This function is used more frequently than the match function, and we will use it in one of our applications in the second part of the course. Actually, we are going to use about 99% of the concepts in this course within those 5 applications. Okay, we will also start using regular expressions, specific syntax, rather than searching for an explicit substring inside a larger string. The syntax for the search function is similar to the syntax for the match function. Let's see it. Let's use the same name for the match object. So A equals re.search. First you have the pattern as the first argument. Then you have the string in which you are doing the search. And finally the optional flags. So you can see that the syntax is very similar with the match syntax. Okay, let's define another string now. We will use an ARP entry from the ARP table of a switch. I have it saved right here. Let's do a copy and paste to save some time. Okay, let's see the string. Okay, now like the match function, Search will return a match object if the pattern is found in the string, and none if nothing is found. It's time to see the search function in action. Let me write this first, and then we will study the syntax. Okay, let's assign this to A. Okay, now, what language is this, you may ask? Well, this is the syntax of a regular expression. Let's take this one bit at a time. First, you can see that the arguments of the search function are, first, the pattern to be matched, and second, the variable which holds the string in which to search for a pattern match. No optional flags this time. Another thing here is the lowercase r, right here, before the pattern. This means that the pattern should be treated like a raw string. A raw string is useful to avoid conflicts between the way Python recognizes an escape sequence and the way the RE module does it. We will talk about escape sequences soon. Now let's dissect the syntax for the pattern. First, notice the parentheses surrounding some of the symbols. Any pair of parentheses matches the regular expression in between them and, as defined by Python's official documentation, indicates the start and the end of a group. So we have a group here, another group here, a third group here, and this is the last group in our pattern. If a match is found for the pattern inside parentheses, so let's say for this group, then the contents of that group can be extracted with the group method applied to the match object. So you can use a.group to extract the matched pattern inside parentheses. Now inside the first pair of parentheses, we have a dot, a plus sign, and a question mark. Each symbol has a meaning and matches something in particular. In regular expression syntax, a dot represents any character, except a new line character. The plus sign means that the previous expression, which in our case is just a dot, may repeat one or more times. So this group will look for at least one character. Any character, doesn't matter if it is a letter, a number, a space, or a punctuation mark, or whatever. Now, remember one thing. The plus sign, which means one or more characters, or one or more repetitions of the expression before it, and the asterisk, so plus, which means one or more repetitions, and the asterisk, which means zero or more repetitions of the expression before it, are both greedy, meaning they try to match as much text as possible. Let me show you what I mean. Let's see what does Python match for the first group of parentheses, having the question mark as it is. To see this, we'll use the group function with 1 as argument, meaning the first group in the pattern. So, let's see this. Let's do a.group of 1. Okay. Now, let's remove the question mark from the pattern and see what the search function returns. So let's go ahead and delete the question mark. And a.group of 1. Okay, notice the difference. In the second case, the plus sign was so greedy that it has included the spaces following it in the matching group. But when we had the question mark in the first case, the match was made in a minimal fashion, matching as few characters as possible. Now we've seen the role of the question mark in regular expressions, so the choice of matching in a greedy or minimal fashion is purely yours. One more thing on this greedy behavior of the plus and asterisk signs. Up to which point is the plus sign greedy in our example? Well, by looking at the ARP entry format, we see that after the IP address there are 6 spaces, then the 0 digit, and then the rest of the line. So here we have 1, 2, 3, 4, 5, and 6. 6 spaces. Okay. That's why inside the regular expression pattern, I typed in a space after the closing parenthesis, so this space over here. My intention was to tell Python that I want to match a group, this group, until a space is encountered. when the question mark was inside the parentheses, Python understood that it should match any character one or more times until the first space character occurs. So this one over here. This was made in a non-greedy way. That's why the matching stopped right before the first space, and we just got the IP address. When I didn't use the question mark, Python understood that it should match any character one or more times as greedy as possible until the last space character is encountered. That's why the matching stopped right before the last space character, so this one over here. Since the matching has been done in a greedy way this time, we got the IP address followed by 5 space characters. So let's count 1, 2, 3, 4, 5. This is because Python stopped matching right before the 6th space, so the last one again over here. Notice that for a correct match result, you should always be careful at both the greedy behavior and the characters following the group, because they act as limits or borders for the pattern you want to match. Now moving beyond the first group, we have the space we talked about, followed by a plus sign. This means that looking at the ARP entry format over here, we are expecting one or more space characters after the IP address. We know that there are actually 6 spaces there, but it is safer to use one space in the regular expression and a plus sign for future compatibility. Maybe you use this regular expression in an automation suite, and the output of showIP ARP may change and have only 5 spaces there at some point in the future. You don't want to have failures into your scripts caused by a fixed number of spaces. Now let's look at the second group. We have a \d there. This is called a special sequence in Python, and it means any decimal digit, so anything from 0 to 9. Python will expect a single digit here. Let's verify this with the group method. So let's do an a.group of 2, because this is the second group, the second pair of parentheses. Okay, so we got 0 as expected. This is the digit we were referring to. Next, we have another sequence of space characters. Let's see it over here. Up to the MAC address. I'm talking about the characters over here. After this, we have a group, the third group, similar to the first one we previously discussed at large. Now let's say we want this group, which would be group number 3, to match a substring consisting of both the MAC address and the VLAN number over here in the ARP entry. And of course the space between them implicitly. For this we use the same dot plus question mark syntax, but we should also specify the limit up to which to consider this group. So the first character or sequence of characters at which Python should stop matching the group. Of course, we could use the same syntax as before with the single space character and the plus sign, but that wouldn't be fun, right? Instead, we can use something even more interesting. First, another special sequence, \s, which matches any whitespace character, whether it is a space, a tab, or a new line character. Secondly, I use the number followed by a comma in between curly braces. This means Python should expect 2 or more occurrences of the regular expression preceding the curly braces, a whitespace in our case, from the \s. Not typing the comma inside the curly braces, I'm talking about the comma over here, would tell Python that it should expect exactly 2 repetitions of the previous regular expression, so only 2 whitespaces. Now, if we would match just a single repetition of a whitespace here, the matching would stop at that one space between the MAC address and the VLAN number, or the VLAN word to be more precise. Instead, by specifying 2 or more whitespaces, Python will know to stop the matching after the VLAN number over here, because that's where a lot of spaces reside. This space is right here. Finally, the \w special sequence followed by an asterisk matches 0 or more occurrences of any word character, meaning letters A to Z and also capital A to capital Z, numbers 0 through 9, and the underscore character. Now it's time to check our groups in the pattern. So let's do a dot group of 1. Okay, we have the IP address followed by those 5 spaces. By the way, let's try and fix this. Let's add a question mark for a non-greedy behavior. Now let's see a dot group of 1. Okay, the IP address. A dot group of 2 will match the digit because this is the second group, so 0. A dot group of 3, as we wanted, matches both the MAC address and the VLAN number. And finally, a dot group of 4 will match the single word character, a letter, at the end of the string. Great, this is exactly what we wanted. Also, remember that a dot group without any arguments and a dot group of 0 both return the same thing, the entire string. Let's verify this. Let's do an a dot group. Okay, so this is the entire string. A dot group of 0, and also we got the entire string back. Another method to use is the groups method, which returns all matches found in a given string in the form of a tuple, where each match is an element of that tuple. So let's see this, a.groups, without any arguments, indeed returns a tuple with all the patterns we matched inside our string. Cool. I think this video is long enough. In the next one, we'll discuss the last 2 regular expression functions. The third function used with regular expression is the findall function. I think this is by far the most used one because instead of returning a match object like match and search did, it returns a list where each element is a pattern that was matched inside the target string. Remember that the findall function, as its name suggests, returns a list of all the patterns that were matched. To see this, let's consider the same ARP entry as the target string. So let's see it. And let's say we want to match the IP address using regular expression syntax and the findall function. The IP address we want to match is composed of 2 digits in the first octet, then a dot, then 2 digits again, then another dot, then 2 digits again, another dot, and finally a single digit. Let me write a solution to this and then I'll explain it. So, okay, let's paste this. Okay, it returns the correct result, but it looks awfully complicated. But I think it's not. What I did is first I typed in 2\d special sequences, meaning Python should expect 2 digits, one after the other. Then I used the \dot. Notice the \dot over here. This is called character escaping, because a dot in the regular expression world means any character except the new line, as we've seen in the previous lecture. In order to match an actual dot inside a string, the dot character itself, you are required to escape it using a backslash. This also is valid for question marks, plus signs, parentheses, and any other characters that have a special meaning in regular expressions. Then, instead of using 2 \ds, I used a single \d and a 2 inside curly braces, which means the previous character should occur 2 times. Then another escaped dot. For the third octet of the IP address, I used the set of characters, as it is called in the regular expressions world, which defines a range of characters, or a character class, which should be expected at that particular location in the pattern. In our case, 0 to 9 doubled, because we have 2 digits right there. Then another escaped dot over here. And finally, I use the same range of characters, 0 through 9, which this time is expected to occur between 1 and 3 times. So either 1, 2, or 3 times. The result is indeed the expected one, a list with only one element, the IP address matched by the regular expression. Let's assign this regular expression to a variable, let's say A. Let's do a type on A, and you can see that it is indeed a list. So you can see that we don't have a match object returned this time. We have a list returned instead. Okay, nice. We can also use grouping with the findall function by enclosing the groups we want to extract in between parentheses. Let's consider the same ARP entry. Let's see it again. And almost the same findall function as before, this time grouping each IP address octet inside parentheses. So let's go ahead and do this. Let's insert parentheses for each octet. Be careful to leave the backslash dots between the octets outside parentheses. Okay. This is the second octet. This is the third one. And this is the fourth one. Okay. Let's see the result now. This time Python returns a list of tuples. So you can see the square brackets and then the parentheses. So we have a list of tuples, where each tuple element is a group from within the pattern. If we would have two IP addresses in the ARP string, then we would end up with a list containing two tuples. Let's check this by inserting another IP address in the ARP string. Okay, let's do a copy from here. And I don't know, let's insert an IP address at random at the end of the file. Okay, let's see the ARP string now. Now let's use findall again to find all matching patterns in the string. This one over here. Okay. Now let's see A. And indeed we got a list of tuples this time. Cool. Lastly, let's talk about the fourth function you should know when using regular expressions. This is the sub function, so re.sub. This function simply replaces all occurrences of the specified pattern in the target string with a string you enter as an argument. Optionally, you can also define the maximum number of replacements to be made using the max parameter. Let's consider the same ARP entry as the target string and replace all digits in the string with the 7 digit. So for this you should apply the sub function like this. Let's say b equals re.sub. First let's enter the pattern. So we are looking for all digits in the string, so we'll use a special sequence \d. Then the replacement for those digits. We said we wanted 7 instead of every digit in the string. And finally the target string, so ARP in this case. Now let's see B. So you see that each digit matched by the \d special sequence was replaced with 7. Great. I know that the regular expressions topic is a hard topic to digest at first. To better understand it and also learn additional ways of matching patterns, check out the link in the additional section of this lecture, and also get into the Python interpreter shell and start playing around with regular expressions. Apart from what we've seen until now, Python has also an object-oriented approach. Up to this point, we have seen one way of programming in Python, using functions and procedures. Object-oriented programming is based on classes, methods, and objects. We will see what each of these terms mean. In short, a class is a data type containing its own variables, attributes, and functions, which in object-oriented programming are called methods. A standard definition for a class would tell you that a class is like a blueprint for creating objects. An object may be regarded as an instance of a defined class, and the attribute values for a particular object define the object's state. Another term that is very used around classes is inheritance. This means that a new class may inherit all the names and functionalities from an existing class. We will talk more about inheritance in the next lecture. Now let's take this one step at a time. First, we should see how to define a class. For this, you will always use the class keyword, then type in the class name. So class. Now be careful here because the convention is to use camel case for class names. This means each word will be capitalized. And also no spaces are allowed. Actually, except the camel case rule, all the rules from function names apply to class names as well. So let's name our class simply myRouter. After the class name, in between parentheses, you should type in the word object, all lowercase. So object. This is the new style of defining classes, starting with Python version 2.2. The thing you should keep in mind here is that if a class doesn't inherit from another class, then you should always type in the word object in between parentheses when defining a class. This is a default setting and it means that this class inherits from a default class named object. I know this may seem confusing, we won't get into any more details on this topic, just don't forget to write the word object. So we have class myRouter of object. Then, as for any code block we've seen so far, we'll type in a colon. And then on the next row, using indentation of course, comes the class content. As with functions, on the first row after the class definition, you can type in a documentation string or docstring in between quotes to give you a hint about that class's functionality. So let's enter some text in between triple quotes. This is a class that describes a router. And close the triple quotes. Following the optional docstring, the first thing you define inside a class is the special init method, also called a class constructor. The role of init is to initialize some variables, and the method is called whenever you create a new instance of the class in which it resides. Actually, it is the first code that is executed when you create a new instance or a new object. Any special method or regular methods within a class is defined using the def keyword, as you do with regular functions. The difference is that each time you define a method inside a class, the first parameter inside parentheses is self. You have to remember to input this word as the first parameter of every class method. Self is no more than just a reference to the current instance of the class. Let's go ahead and do this the right way. So def double underscore init double underscore the self keyword. Now, after typing in self, you define any other parameters that you want to be defined and initialized whenever you create a new instance of the class. In our case, we want to define some parameters that characterize our router. So, let's say separated by comma, router name, comma, model, serial number, and iOS. Now, as with any other class or method definition, you type in a colon. Then on the next row, indented of course, you will define the object or instance attributes we need to describe the router, according to the parameters of the init method. Remember that self is used to point out that we are referring to the current instance of the class. So, self dot router name equals router name. Then self dot model equals model. Self dot serial number equals serial number. And finally self dot iOS equals iOS. So that's how you define object attributes. Now let's also define a method inside this class that will do nothing more than just print out the attributes and concatenate the model with the date. Let's define print underscore router as our method. The first parameter is self, and let's say manufacturing date. Okay. Notice that self is again inserted as the first parameter here. You should do this for every method you define inside the class. So now let's write the body of this method. Let's say print the router name is colon a space for better readability, and then self.router name. Okay, I typed in those print statements just to save some time. Now let's see what's the deal with the objects we talked about so much. An object is actually an instance of the class. You can create as many objects as you want or need by simply calling the class name and entering the arguments required by the init method in between parentheses. So these arguments right here. All of them except self. This is passed by Python automatically, so don't worry about it. Now let's create our first object. Let's say router1 equals the class name, my router, and then the arguments for the init method. So let's say R1, the model 2600, some serial number, and the iOS version. Okay, now let's check router1. Indeed, we see that we have created an object right here. Now what can you do with this object? First, you can access its attributes like router name, model, serial number, or iOS. Let's see this. Router1 dot, and then you type in the attribute name. Let's say model. Okay, we got 2600, which is correct. Let's try this with iOS 12.4. Okay. Let's check the serial number. And finally, the router name. Great. What else? We can access the method we defined, print router, over here. The method borrows the attributes defined in the init method and uses them within its own block of code. So you see them right here. Also notice that we should specify a value for the manufacturing date parameter, this one, when calling this method. Again, self is invoked by Python in the background, so you shouldn't worry about it. To use the object for calling the method, we'll do the following. Router1, so the name of the object, dot, and then the function or method, better said method, name, print, underscore router, and in between parentheses, you give the argument which the function requires. So the date, let's say something in the following format. 2015 0101, enclosed by quotes. Okay, enter, and we can see that the function was executed, the method was executed correctly, and all the print statements are printing what they should. Now let's create another object and do the same operations just to prove we can create multiple objects. So let's say router2 equals the class name, my router. Then in between parentheses, let's type in some arguments. So R2 for the router name, 7200 for the model, serial number, and finally another iOS version, let's say 12.2. Okay, now let's access the object attributes, router2 dot model dot router name dot iOS, and finally dot serial number. Great, now let's also access the method within the class, so router2 dot print router and the manufacturing date as an argument, so let's say 2015 0202 as a string. Okay, great, this worked perfectly. You are also able to change an attribute of an object, like this. Type in the object name, so let's say router2.ios equals, let's say 12.3. Let's check its value now. Now it's 12.3. Notice that before it was 12.2 over here. Python also provides some functions to play around with object attributes. Let's see them. First, we have the getAttr function for getting the value of an attribute. Let's use it on the router2 object. So, getAttr. First, you enter the object name and then the attribute name. So, we got 12.3 as expected. Okay. We can also set a new value for an attribute using setAttr. So, let's say setAttr. The object is router2. The attribute is iOS and the new value 12.1. Okay, great. Now let's use the previous getAttr function to see the new value of iOS, and indeed it is 12.1. Another function you can use is hasAttr to check if an object attribute exists. Let's say we want to check if router2 has the iOS attribute defined. So attr, the object is router2, and the attribute we are looking for is iOS. Okay, this returns true because iOS indeed exists in the class. Now let's do the same thing with, I don't know, iOS2, and this returns false as expected. Finally, you can delete an attribute using the del attr function. So let's do a del attr on router2, and we want to delete the iOS. Okay, now let's check if the object still has this attribute. So we will use hasAttr, and indeed it doesn't have it anymore because it was deleted. Let's also see what is the error when trying to get a non-existent attribute. So let's say getAttr for object router2 and an attribute, let's say the same iOS because this doesn't exist anymore. Okay, so as expected, we got an attribute error. This is a new error we see in this course, saying that this instance of class myRouter has no attribute named iOS. We can also verify if an object is an instance of a particular class. This is useful, especially when you have multiple classes and objects created. Let's see it in action for object router2 and our class. So you should use isInstance router2 and the name of the class, myRouter. And we got true returned, because indeed router2 is an instance of class myRouter. In short, this is how object-oriented programming, or simply OOP, works. We will not use classes and OOP to build our applications, although we could do it. It is purely a matter of choice, and to be honest, I like the classical way of programming more. Next, we'll have a look at class inheritance. We've seen that when creating a new class, we should type in object in between parentheses when defining the class. We can say that the new class inherits from the class called object as a default. But for the sake of modularity and the do not repeat yourself best practice in Python, we can also create a class that inherits the attributes and methods from an already existing class. This is called class inheritance. In this case, the class inheriting the attributes and methods is called a child, and the class the child inherits from is called, you guessed it, a parent. To tell Python that you want to inherit from a certain class, you should type in the parent's name in between parentheses instead of object when you define the child. Let's see this. We still have the old class, myRouter, in memory from the previous lecture. This will be the parent. And let's see it. Now let's create the child and name it myNewRouter. So class myNewRouter, remember the camel case, inherits from myRouter because that's the parent, colon. Now about the double underscore init double underscore methods. You are allowed to skip the definition of an init method for the child class because the new class, myNewRouter, actually extends the myRouter class, and the init method is inherited from the parent. But what if you want to inherit all the attributes from the parent class and also define new ones in the child class? Then you are required to redefine the init method, tell Python that you want all the attributes in the parent to be available inside the child, and then enter new attributes. I will write the init method for this class and then I'll explain every bit of code. So, first I define the init method using the def keyword. Then in between parentheses I pass the arguments as they are written in the parent class, so router name, model, serial number, iOS. But since I want to define a new attribute for this class, namely the number of ports number, I added this parameter at the end. On the next row, I called the init method from the parent class by typing in the parent class name, so myRouter, then a dot, and then the init method, having the same old parameters in between parentheses as it has them in the class definition. I actually imported, so to say, the init method attributes from the parent class. Finally, I defined the new attribute specific to this class only called ports number, and that's it. Now I will define a new method inside this child class that simply concatenates a string given as argument when calling the method and the value of the model attribute inherited from the parent class. So let's say def print new router of self, don't forget the self word, and string colon, and just print string plus self.model. Okay, now let's verify the inheritance process by first creating an instance of the child class. So let's say new router1 equals my new router, so the class name, and let's input some arguments. This is the router name, then we have the model 1-800. Now let's enter a serial number, then an iOS version, and finally a number for the number of ports. Notice that this time when invoking the child class, you should also add a value for the number of ports as the last argument. Okay, now let's see the attribute for the number of ports. So new router1 dot ports number. Okay, we got 10. This is correct. Now let's see if we can access the attributes from the parent class using this instance of the child class. So let's say new router 1 dot model. Okay, great. Let's also use iOS 12.2. Great. Now let's access the method from the parent class using the same instance or object. So new router dot print underscore router, and let's type in some random string. Okay. And indeed, the method inside the parent class is executed successfully. Nice. Now let's do the same thing with the method defined in the child class called print new router. So new router1 dot print new router. Okay, another string, and this is successfully executed too. Two more things on class inheritance. First, a child class can inherit from two or multiple parents. The difference is that when you define the class, you should enter all the parents in between parentheses, like this. Let's say class, child class, and in between parentheses you enter the parents. So let's say parent1, comma, parent2, comma, and so on. I don't know, comma, parent n. And this is how you define multiple inheritance. The second thing I'll show you is a function that checks if a class is the child of another class. Let's use it with the classes we defined. The function is called isSubClass. And first you type in the child class, so my new router, and then the parent class as the second argument, so my router. Okay, this will return true or false. In our case, it is true, obviously. I think you now have a pretty good idea about classes, objects, and inheritance. Of course, the object-oriented programming topic is much more complex and cannot be exhausted in just a few lectures or even an entire course. You can find a link in the additional section of this lecture with more information about classes. Okay, Python and MySQL. The first thing we should do is set up the database in order to play around with some database inserts, updates, and queries. Although Python has modules available for other relational database management systems as well, like Oracle, Microsoft SQL, or PostgreSQL, I chose MySQL because it is the one I've worked with in the past and one of the most widely used. On the virtual machine you got from my drive, let's open a root terminal and verify that MySQL is installed, and then let's start the MySQL service. To start the MySQL service, use this command, service MySQL start. As you can see, it is already started on my machine. Now it's time to log into the database with the root user, which is the user with most privileges in a MySQL environment. The password to this account is also root, so let's go ahead and do this. MySQL -u for username, root, and -p. Enter. Now you type in root, R-O-O-T. After logging in, you can see some information about this MySQL server release. It looks like I'm using version 5.5.41, but it's important that you have the same major release, which is 5.5. Now I'm gonna start creating a database, and you should follow me and create the same database because we will use it in one of our applications, and we should have the same things configured. So, without further ado, the first command will create the database itself. So, create database. Let's name it netmon. And now we have a new database in our system. So you see that our database was created. There it is, netmon. The other entries in this table are some default entries that MySQL creates, so you shouldn't worry about them. The next step is to create a regular user that we are going to use for all operations on this database. The way to do this is the following. Create user. I named my user TEOPY and localhost identified by Python. Okay, it looks like I did a spelling error here, so identified. Okay, so I have created a user, assigned it this password, Python. Pretty straightforward, I think. Next, we should tell MySQL that we want this user to have all privileges on the netmon database. So this is how it's done. First, use netmon. This command references our database, gets it in use actually. Okay, now grant all on netmon dot and a star, an asterisk, to TOPY and localhost. Okay, notice that at the end of each command, you should type in a semicolon. That is the syntax of SQL. Now it's time to create some SQL tables in which we are going to store information using Python. We'll create 5 tables in this database. First, I should tell you what this database is all about. One of our applications that we're going to build later will extract some parameters from the routers in GNS3, parameters like the CPU or processor utilization on each switch, memory utilization, and the number of interfaces that are up. Also, it will calculate an average of each of these parameters and input these values in the corresponding MySQL table, along with the timestamp for each extraction and the top 3 CPU-intensive devices or memory-intensive devices. Further, using the Linux cron tab, you can schedule that Python application to run every 5 minutes, for example, and each time add the values it finds on the routers for statistic purposes and network monitoring. And now you know why our database is called netmon. Now let's get back to creating the tables. The first table will have the role of a device inventory. Here we are going to store different information extracted from each router, like the host name, the model, the iOS version, uptime, or routing protocols running on each of them. So let me copy the command because it is pretty long. Okay, paste it right here. I have attached this txt file to this lecture. Here you can find the commands I'm going to use to create tables and populate them, so you can just copy and paste them into your MySQL shell. So, this table is called network devices, and the columns of this table will be called hostname, MAC address, vendor, and so on. When defining an SQL table column, you should also specify what type of data will be stored in that column. For example, varchar means a variable length string having the maximum length given by the number that follows it, so 30 characters right here. Int means an integer, and you will also see other data types as well. Now let me create the other 4 tables, also by copy and pasting them. The first thing we notice here is the new MySQL data type, and this is float, followed by 2 integers in between parentheses, separated by a comma. This means that floating point numbers are expected here, and not just any numbers, but floating point numbers with a maximum of 6 digits, including the decimal point, of which 2 digits should be after the decimal point. So something like, let's say, 123.45. Okay, so we have the CPU utilization table for information about processor usage, the procmem utilization table for information about the memory that is allocated to various processes on the router. Then we have the IO mem utilization table, which refers to memory dedicated to traffic like routing updates or broadcasts. And finally, the up Ethernet interfaces table, which holds data about the number of up interfaces in the network. To see the tables you created, use the show tables command. So show tables and the semicolon. Now to see a specific table and the columns it contains, use the describe command like this. Describe and then the name of the table, let's say network devices. Okay, now it's time to do some operations on one of our tables. Insert some data, query the database, and other fun stuff. Let's take the network devices table, for example, and see how to create a row in this table. Well, actually 2 rows, using the insert into SQL command. So let me paste the command here and then explain it. Okay, so we have insert into, this is SQL syntax, the table name, then all the columns in which you want to input data in between parentheses, so up until this point, then the values keyword, which is also SQL syntax, and then the values for each column in order, in between parentheses, and that's it. And don't forget the semicolon at the end. Okay, now let's change a few values and insert another row. So let's change some values. Let's say 12.2. Let's change the model. Okay. Well, we got an error because the Mac ADDR column is also a primary key. This means that each value in this column must be unique. So I forgot to change the value for the MAC address. I'll go ahead and do this right now. Okay. Now it's great. Okay. Now you can verify the data in the table using the following command, also called a query. So select an asterisk, which means all, from, and now the table name. Let's say network devices. Okay, it doesn't look too pretty because it has a lot of columns, but you should get the idea. Okay, the last SQL things I'll show you before closing this lecture are a couple of other SQL queries. For example, let's create a simple query that returns the rows in the table for which the iOS version is 12.4. So let me go ahead and type this. Select all from network devices where iOS version equals, and in between simple quotes or single quotes, 12.4 and a semicolon. Okay, so we got this row in the table right here because this is where we got the 12.4 iOS version. Okay, pretty cool. Now let's do another one. Let's say you want to find out the router host names in your network that run BGP. So you would write this query. Select host name, because we only want the host name to be displayed, from network devices where ext routing row equals, and in between single quotes, BGP. Of course, in our case, we have only 2 routers, both running BGP, as you can see right here. No, right here. Okay. So both of them are returned. Now, the last one, I promise. Let's say you want to see how many of the routers registered in your database are running each iOS version. This is a bit more tricky. You'll do something like this. Select iOS version, comma, count of iOS version from network devices. And now another keyword, actually two keywords, group by iOS version, and a semicolon at the end. So indeed we have one router with version 12.2 and another one with version 12.4. Great. I'm not going to get deeper into SQL and MySQL. There are other courses that do that. I just wanted you to grasp some basics so you will know how can Python interact with MySQL, and that's what we'll see in the next lecture. Okay, we've seen the basics of MySQL. We have a database set up on our virtual machine, actually on the same virtual machine where we're going to run Python, so Python will interact with the database stored on the local host. Of course, Python can interact with the database on other hosts, but for simplicity, we are going to use the same virtual machine. I will add a file to this lecture detailing some settings you should make for accessing a database on a remote Linux host. You should check that out. Anyway, back to our scenario. Let's use Python to do some operations on our database. Make sure you have two root terminals open, one with the MySQL shell and the other with the Linux shell. In this second terminal, we are going to create a new file and do all of our work inside that file. I think this would be much easier than doing it in the Python interpreter. So let's go ahead and create a file. Let's say touch.sql.py. First, we should import the MySQL database module, which I have already installed for you on the virtual machine. So let's open the Python file and start doing the fun stuff. sql.py, I for insert. So the first thing we should do is import MySQL DB. Notice I used import as. This basically creates an alias for the module name. So when you reference variables and functions inside that module, you will type in a shorter name as a prefix to that variable or function. You should see this as an abbreviation of the module name. So now let's define some variables that we are going to use to connect into the MySQL database. So let me paste them. Here they are. Okay. Now let's connect to the database using these parameters. For this, we are going to create an SQL connection that calls the connect method from the MySQL database or MDB module and pass our variables as arguments to this method. So let's call this SQL connection equals mdb.connect, and in between parentheses we are going to enter the parameters we just defined. So SQL host, SQL username, SQL password, and finally SQL database. Okay, and for now let's just print SQL connection and save our file. Now let's run it. So python sql.py. Okay, so now you can see that we have a MySQL connection to the local host. Now let's use it. Let's open the file again and comment the print statement. So I for insert and the hash sign. The next step is to create a cursor object. This cursor helps you execute different commands on the SQL database. So let's create one and initialize it for the connection we just opened. Let's say cursor equals SQL connection dot cursor. Good. Now it's time to use this cursor to execute some commands in our database. The first command we should execute is the one specifying the database we will refer to. So cursor.execute, and in between parentheses and in between double quotes, let's type in use netmon as we did in the previous lecture. Notice that this time the semicolon can be skipped. so don't worry about it. The semicolon is mandatory in the SQL shell though, so remember this. Now let's create a new table in our database using Python. So first let's check the existing tables. Show tables. Okay. Now let's create a new table using cursor.execute. So cursor.execute. Now let me type in the command. So this new table called from Python will have 3 columns. The first will have a data type of varchar. The second will host only integer values, and the third column will have floating point numbers. Now, before checking our application, let's also save our database content. In the MySQL shell, you would do that with the commit command like this. So commit and a semicolon. In Python, you can execute the same operation with the commit method. So let's go ahead and do this. SQL connection dot commit. And the final step should be closing the SQL connection, which is done using the close method. So SQL connection dot close. Now let's save the file and run it again. Let's check our database now. So show tables. And success! Our table was created right here. Great. Now let's see its structure. Describe from Python. So we have all the columns and data types in place. Nice. We made Python communicate with the MySQL database. This opens a lot of opportunities. Let's insert some data into our table. Let's make a query. This way we can play with our new toy. First, let's insert a row into the table. Since the table already exists, we should comment the line that creates it, just to avoid the MySQL error. So let's go ahead and do this. I for insert. We'll comment this. Okay. And now we should write a new line. So let's type it here. Cursor dot execute. Okay, so I typed in the insert statement. So we have insert into from Python. This is our new table in the database. Then we have the column names, the values keyword, and the values we are going to insert. So string for column 1, 10 for column 2, and 123.45 for column 3. Okay. Now let's save the file and run it one more time. Seems like we have a syntax error. I think we should use single quotes because we used double quotes to enclose the insert statement. So let me go ahead and try this. Sorry. Let me replace the double quotes here with single quotes. Okay, let's save it one more time and try to run it. Okay, great. This time it worked. Now let's check our table by doing a select all from Python. And success again. We have inserted some data into an SQL table using Python. Cool. Finally, what if you want to execute a MySQL query on the database? Like the one we just did, select all from Python. How would you do that from within a Python application? The first step is to use the same cursor.execute method to send and execute the command into MySQL. So let's comment the line inserting data and write a new one. Okay. Let's say cursor.execute and in between double quotes select all from Python. Okay. The second step is to capture the output and maybe store it in a variable. This is done using the fetch1, fetch_many, or fetch_all methods. Fetch1 fetches a single row of a query. Fetch_many returns the number of rows you input in between parentheses, and fetch_all fetches all the rows returned by the query. From Python's point of view, each row in the table is going to be returned in the form of a tuple. So let's do it. Let's apply the fetch1 method to the cursor because we have a single row there anyway, and store the result in a variable, and of course print the value for that variable. So let's say output equals cursor dot fetch one without any parameters, and of course print output. Now let's save it and see what we get back. Great, except one thing. Notice the capital L following 10? This means a long type, although we had 10 as an integer in MySQL. This is due to some issues when converting integers using the MySQL module. No problem, this can easily be fixed by applying the int function in Python on that tuple element, something like int of output of element at index 1. And that's it. Okay, I think we're about done with Python and MySQL. Of course, many other things can be done in MySQL using Python, but that could be the subject for an entire course. The concept of comprehensions allows us to build sequences from other sequences in an easy, quick, and elegant way. Let's start working with list comprehensions because they are perhaps the most widely used. They are actually a quick alternative to something we've already seen and used thus far. Let's say we have a list and want to iterate over it and perform some action on each element. We would use a for loop, right? Let's build a list of all the elements in range of 10 and raise them to the power of 2. First, let's define an empty list. This is where the resulting elements will be appended. So, let's say list1 is an empty list. Now it's time to iterate over a range of 10 and do the math and appending to list1. So let's say for I in range of 10, let's define j equals I to the power of 2, and then list1 dot append of j. Okay, so what we did here is a for loop. We are looping through the list generated by a range of 10, so 0 through 9. We raise each element to the power of 2 and then append it to our empty list over here. Good. Now let's see the results. Nice, we got the result we wanted. But what if we could write this whole block of code in a single line? Python allows you to do this using a list comprehension. Let's see it in action. Let's define list2, and let me write this first. X to the power of 2 for x in range of 10. Let's see list2. So we've created list2. Then, in between square brackets, because we are trying to build a list, we first write the action to be performed on each element, so x to the power of 2. Then on the same line, without any colons, commas, or indentation, we write the loop structure as we would in the old-fashioned way, so for x in range of 10. Pretty cool, I think, and pretty useful. The result is correct, and it is the same as list1, as you can see. Great. But what if you want to enter a conditional statement in this looping construct? Let's say you want only the numbers greater than 5 to be raised to the power of 2. The solution is to enter the if statement after the for statement at the end of the list comprehension. Let's do this. Let's build list3 equals square brackets x to the power of 2 for x in range of 10. Sorry. And now the interesting part, if x is greater than 5. And that's it. So as you can see, we have the for statement in the middle. On the left side, we have the action to be performed, so x to the power of 2. And on the right side, we have the conditional statement, if x is greater than 5. Again, no commas, no colons are needed. And now let's see the result. List3. Okay, great, just what we wanted. Now let's see set and dictionary comprehensions. The way to build and write them is the same as for list comprehensions. The only difference is the enclosing character for the comprehension. So, for both set and dictionary comprehensions, we use the curly braces as enclosing characters. Let's better see an example for each of them, starting with sets. So let's say we have set1 equals, open and close curly braces, x to the power of 2 for x in range of 10. Okay, now let's see set1. Let's do a type on set1 to confirm that it is indeed a set. Okay, so indeed we build a set using a set comprehension. Cool. Now for dictionaries. Let's remember that dictionary elements are actually key value pairs, where the key is separated from the value by a colon. This is the format we should use for dictionary comprehensions as well. So, let's create dict1 equals, open and close curly braces, x colon x plus 1, so this is the key value pair, for x in range of 10. Sorry. Okay, and that's it. Let's see dict1. Great. Let's do a type on dict1. Okay, and now we have a dictionary built from scratch using a dictionary comprehension. Of course, you can have nested for loops or if statements, and you can do many other types of operations or iterations inside the comprehension structure. I just wanted to show you a basic set of operations so that you get familiar with the comprehension concept itself. I think that list, set, and dictionary comprehensions can be a useful and elegant way to write some code, especially when you want to perform simple for loops and save some space within your program. Keep them in mind. I can guarantee that you will need them at some point in your programming adventure. Python allows us to create small anonymous functions at runtime called Lambda. Lambda functions are a great Python tool, enabling us to quickly insert some functionality into our code, especially in places that would not allow the definition of a regular function. You know, using the def keyword, the return statement, and all that. Unlike regular functions, you can embed a Lambda function wherever you want inside your code, and you don't need a return statement to output something from that function. Although not mandatory, you can assign a Lambda function to a variable, so you can use that variable further into the program. If you don't, then the Lambda function will run right there where it has been created, then the result is thrown away. Without further ado, let's see the general syntax for Lambda functions and then some examples. So we have something like this: Lambda, argument 1, argument 2 separated by comma, and so on up to argument n, a colon, and then expression using arguments. Okay, let's do a couple of examples in the Python interpreter shell, and let's assign the Lambda function to a variable in each example. So first, let's say a equals lambda x comma y. These are the function arguments, a colon, and let's say x times y. And that's the Lambda function definition. Now let's check that this is indeed a function. Let's see a. So you can see function Lambda and the memory location. Let's do a type on a. So type of a, it's function. It is a function. Okay, cool. Now let's call our function and give it some arguments to multiply. Let's say a of 2 and 10. We got 20. Okay, cool. A, of 100 and 100. And we get 10,000. Okay, great, it works. See how easy it is? Now let's do another example. Hold on tight, this will be a nice one. Let's combine the Lambda function and the list comprehension, in which we'll have a nested for loop. But first, let's do this old-fashioned using a regular function and a regular for loop syntax. Let's say that we want to obtain a list with all the results of multiplying each element in the list generated by range of 10, so 0 through 9, with each element in the list generated by range of 5, meaning 0 to 4. and concatenate this list with a list given as argument to the function. How would we normally do this? Well, we would create a function, a for loop nested inside another for loop, and then return the list of results concatenated with the list we passed as an argument. So let me write this first. Def, let's call our function myfunc of list. So this function accepts only one parameter, a list. Okay, colon, an indent. Let's say prod underscore list equals empty list. So we initialized an empty list to store the product results. Now the for loops for x in range of 10, colon, then the nested for loop for y in range of 5. Sorry, I got this all wrong. Let me use the up arrow key to get back. Okay, for x in range 10, for y in range 5. I didn't use the colon. Okay, now inside this nested for loop, we are going to do the math. So product equals x times y. We are storing each result in the product variable. Okay, and then prod list dot append of product. So we append each value to the prod list list. Okay, finally we should have a return statement. So return, we said that we wanted to concatenate the prod list, so prod list, with the list we pass as an argument to the function, so plus list. Okay, now let's call the function and pass a list as an argument, so myfunc, and let's use some elements for this list, 100, 101, and 102. Okay, so we got the expected result, a list made of the multiplication results, at the end of which we added three elements, 100, 101, and 102. Now we can achieve the same result with just one line of code, using the Lambda function and list comprehension. Let me type in the line of code first. So let's say b equals lambda list, because this is the only argument this function takes. Now for the list comprehension, we use the square brackets, so x times y for x in range of 10. Now for the nested for loop, for y in range of 5, we should concatenate this list with the list given as argument, so plus list. And that's it. So after the lambda keyword, we have a single argument, list. Then instead of initializing a list and writing the for loops and appending the results to that list, we use the list comprehension with a for loop nested in another for loop without having the need for colons or indentation. Finally, we added our own list to the list created by the list comprehension, and that's it. Now let's check the results. So let's use the same list as we did earlier, so b. As you can see, we achieved the same result with a lambda function and a list comprehension using one line of code instead of 1, 2, 3, 4, 5, 6, 7 lines of code. Lambda functions are widely used in conjunction with three other Python functions, map, filter, and reduce. We will discuss them in the next lecture. Let's talk about three useful functions that Python provides and that are very often used along with Lambda functions. First, we have the map function. So this is the function map. This function takes another function and a sequence as arguments and applies the function to all the elements of the sequence, returning a list as the result. The function taken as the first argument may be a previously defined function or a lambda function. So let's try this first using a predefined function that we will create. So let's define a function that takes a parameter and multiplies by 10. Let's say def product 10. of a colon and just return a times 10. Okay, now let's create a list. Let's say list1 equals range of 10. Let's say list1. Okay. And now let's use the map function to apply the product 10 function on each element in the list, in list1. So, map, open parentheses. First you type in the function name, so product 10, and then the sequence name, list1. Great, just what we intended. Now let's do the same thing using a lambda function. So, map, open and close parentheses. The first argument is the function, in our case a lambda function this time. So, lambda a times 10. Okay, enclose this in another set of parentheses, and then comma and the list we want to apply the function on. So the result is the same in a single line of code. Notice that the lambda function body may or may not be enclosed by parentheses inside map. You should better use parentheses though for better readability. Remember, readability is one of Python's main advantages. The filter function, so filter, also takes a function and a sequence as arguments, and its role is to extract all the elements in that sequence for which the function returns true. Let's go ahead and use a lambda function and the same list1. So let's say filter. The first argument is the function, so lambda a. Let's say a greater than 5. And the second parameter is the sequence, so list1. Close parentheses. And this is pretty intuitive, I think. The lambda function returns true if, applied on list 1, it finds elements greater than 5. Then the filter function returns a list composed of those elements only. Finally, the reduce function is a bit more complex. Reduce also takes as arguments a function, usually a lambda function, and a sequence. Now let me explain how it works. Let's say you have the following code. Reduce myfunc, comma, and then the sequence. Let's say 1, 2, 3, 4, and 5. A simple list. Now what reduce does is it takes the first two elements of the sequence, so 1 and 2, and feeds them as arguments to the myfunc function. Then it takes the result returned by that function and the third element in the sequence, in our case 3, and then feeds those two as arguments to myfunc, and so on until the sequence is exhausted. The final result will be a single value, not a list of values as we've seen with map and filter. Let's see a couple of examples using the same list1. So let's go ahead and delete this. Let's say reduce. The first argument is the function, so lambda a and b. Let's take two arguments, and a times b as the operation, and apply this on list1. Wait, that's not the best example because list1 is range of 10, remember? And the first element of the list generated by range of 10 is 0. Thus, the final result, having multiplication inside the function, will be 0. Let's try the same with addition instead of multiplication. So, let's say a plus b. Okay, so we got 45 as the final result. This is actually the sum of all elements in list 1, right? We can confirm this with the sum function. Let's say a sum on list 1. Okay, indeed, 45 it is. We can apply the same principle for subtraction. So, let's say a minus b. And this time we get minus 45, which is also correct. Let's use the reduce function with a string being the sequence and add a space in between every two letters of the string using the lambda function. So let's say reduce. lambda a and b colon, and let's concatenate a plus a space character and plus b, comma, and now the string we want to apply the function on, let's say networking, and that's it. Great, we got what we wanted. So remember these three functions that Python provides to help you deal more easily with different tasks. They may come in handy someday. Every process running in an operating system contains at least one thread and can initiate multiple threads, which are then executed in parallel in the same process space. This is similar to executing multiple applications at the same time. In Python, threading can be used to run several function calls or other tasks simultaneously, especially if those tasks involve some waiting. This is the case for networking and web-related tasks. Threading is a large and advanced topic in Python. We will discuss only the basics of threading in this course because we will use it in one of our applications. Python provides two modules for threading. They are called thread and threading. When using any of these modules, you should first import them using the same old import statement. Note that the thread module is considered obsolete and it is recommended that you use the threading module instead. This is available starting with Python version 2.4. Now, referring to the threading module, we will use the thread class from this module, written with a capital T and prepended, of course, by the module name. From this class, the most useful and used methods are, first we have start and join. Start simply starts or initiates the thread, and join makes sure the program waits for all threads to terminate. Okay, let's see an example of threading in Python. Let's create a file in which to write our code. So, touch thread.py. Okay. First, we should enter the file and edit it. So, I for insert. Okay, the first thing we should do is import the threading module. So, import threading. Also, we will need a module we haven't talked about yet. It is called time. So we will import this too, just to show the threading functionality. So import time. From the time module, we will need the sleep function, which basically interrupts the execution of the program for as many seconds as you enter in between its parentheses. So, for example, time.sleep of 1 will hold the execution for a second. Okay, let's delete this. I said that threading can be used to run several function calls at once. So let's first define a function that prints something, then waits for 3 seconds, and then prints another thing. I'll use this simple function just to prove that using threading you can run multiple function calls simultaneously. So let's go ahead and define our function, def myFunction, open and close parentheses, no need for any arguments. Let's say print start a thread. Then we have time.sleep for 3 seconds, and then print another string and a thread. Okay, now it's time to configure threading. But first, let's set a goal for this application. We would like to run the function 5 times concurrently, and as a bonus, we would like the program to wait for all threads to terminate. To achieve our goal, I'll first create an empty list called threads. So threads equals empty list. Then, because we want 5 instances of the function to be executed, we can make use of a for loop and the range function. So let's say for I in range of 5. Now let's use the thread class from the threading module and tell it the target function to be executed. We will do this using the target argument. So let's say th equals threading dot thread, and in between parentheses, let's define target as being our previously defined function. So my function without the parentheses. Okay, now it's time to start the thread and then also append each threading object to the threads list. So, as I said in the beginning of this lecture, you will use the start method to initialize a thread. On the next row, th.start and also threads.append of th. Finally, using another for loop to iterate over the threads list, we will use the join method in order to instruct the program to wait for all threads to finish. So let's say for th in threads, go ahead and th.join. Okay, now let's save the file and run it to see threading in action. So python thread.py. Okay, this clearly demonstrates that the function is called concurrently because it printed the first string 5 times, then stopped for 3 seconds, and then printed the second string 5 times. If we would have called the function 5 times without using threading, then what would have happened? Well, the first call would have printed the first string, then waited for 3 seconds, and then printed the second string. Then all the subsequent function calls would have done the same thing, so a total of 15 seconds of interruption. Let's see this by modifying the program to not use threading, but instead just call the function 5 times. So let's go into the file, I for insert. Let's go ahead and delete this. Okay, so for I in range of 5, just run my function. Let's save it and run it. This will take a while, but let's see the results. Okay, so there it is, the difference between normal function calling, this, and threaded function calling, this case. I think you now have a pretty good idea about threading. Hi guys, let's talk about a slightly advanced topic in Python, iterators and generators. Let's start with iterators. According to the official definition, an iterator is an object which allows a programmer to traverse through all the elements in a collection, regardless of its specific implementation. In Python, we have the iter function that takes the iterable object and returns an iterator. Now, because I'm not a big fan of definitions and long speeches on theoretical topics, let me get into the Python interpreter and see how can we use an iterator. So, Python, okay. First, let's consider a list. Let's say my list equals 1, 2, 3, 4, 5, 6, 7. Okay. Now, using the knowledge we have about iterations, how would we traverse this sequence to get each element printed out? Well, using a for loop, right? Let's see this. For element in my list, colon, print element. Okay, simple enough. Now let's use the iter function I was talking about to create an iterator. We can do this pretty simple. Just type the object name and then use the function. So my iter equals iter of my list. Now let's confirm that this is indeed an iterator, of course using the same old type function. So type of my iter. Okay, so we got type list iterator. Nice. Now how can we use this to our advantage? Well, here's where we get to learn a new method, which is called next. To use it, we just have to apply it on our iterator. So my iter, dot next, and we get 1. Okay. Let's do this one more time. 3, 4, 5, 6, and 7. Okay. So notice that each time we apply the next method to our iterator, we get a new element in the list. Pretty cool. Now, after exhausting all the elements in the sequence, what would happen if we use the method one more time? Well, let's test it. Okay, so we got stop iteration, meaning you have reached the end of the sequence. Now, why do we use iterators? Well, first because they are simple and elegant to write and implement, as you've just seen. Secondly, they save computer resources because you can access only the next element in the list or string or whatever sequence you have, without having to keep all the elements in memory and then have them returned. Other things can be said and tested in relation to iterators. I just wanted you to know about them, see how to use them, and keep them in mind as an iteration method. Now let's look at generators. The formal definition says that a generator is a special routine that can be used to control the iteration behavior of a loop. Similar to a function, a generator is defined using the def keyword, can have parameters, and it can be called. As opposed to a function, which returns an entire array with all the values, a generator function yields the values one at a time. That's why it can be also called a resumable function. You can traverse a sequence up to a certain point, get the result, and then actually suspend the execution. Later, you can return to that point and resume the execution. This is a great advantage because this way less memory is required. Let's see how a generator function works. Let me write such a function and then we'll discuss it. So, let's say def mygen of x and y, colon, for I in range of x. Let's print I is, let's use a format operator just to remember them. Okay, I. Let's also print y is percent and y. Okay. And finally, here is the interesting part. Yield I times y. Okay. So as I said, you use the def keyword to define the generator function, which takes two parameters, x and y. Then using a for loop, you iterate over a range of x, print the values of y and y, and then yield the result of multiplying each element in range of x with y. The yield keyword suspends the function execution and sends a value back to the caller. It also saves the state of the execution, so when the execution is then resumed, the control picks up after the yield statement. Very interesting. Let's see this in action. Let's create a generator object first. Let's call it myObject equals mygen of, let's say, 10 and 5. Okay, now we should check that we have indeed created a generator. So let's say myObject, okay, generator object. And let's also try type of myObject, type generator. Okay, so we have a generator created, good. Now let's use the next function to manually get the next element returned by mygen. So each result of multiplying I with y, one at a time. So let's say next of my object. Okay. So for the first run of the next function, we got I is 0 because this is the first element in range of 10. Remember we made x equal to 10 when we created the generator object. So I is 0, y is 5, and the result of multiplying them is, of course, 0. Now let's run next again. So this time we get the results of the next iteration where I is 1, y is still 5, and the final result is now 5. Let's see all the iterations one at a time until the list generated by range of 10 is exhausted. So 25, 30, 35, 40, 45, and of course, in the end, we get stop iteration because all the elements of range of 10, meaning 0 through 9, were exhausted. Pretty nice. Finally, let's look at another type of generator construct, generator expressions. They are very similar to the comprehensions you saw earlier in the course, only this time we use parentheses instead of square brackets like we do for list comprehensions, for example. Let's do a very basic generator expression, and let's then see what we get as a result. So, genexp equals parentheses, and in between parentheses, let's say x for x in range of 5. Let's see genexp, generator object. Let's do a type on genexp, type generator. So we get back a generator object, which we can now use to extract each value in the list generated by range of 5, one value at a time, using the next function. So let's try this. Next of genexp. Okay, 0, 1, 2, 3, 4. And since 4 is the last element in range of 5, we got stop iteration. Cool. I hope you enjoyed this course update and learning new Python concepts. Thank you. Okay guys, so let's see how to install a new Python module on your Linux operating system. I'm currently on my VirtualBox, on my virtual machine running Debian 7 Linux. And I'm going to show you how to install a brand new Python module. For this, I've gone to pypy.org. This is the website you are going to use to download mainly most of your Python modules that you are going to need. It has hundreds or thousands of Python modules available for download. I picked one at random. It is called concheck, and we are going to use it as an example in this lecture. So the first thing to do is to click on this .tar.gz archive and download it to your operating system. Okay, just click save. Download it to the downloads directory. This is the default directory. Okay. Let's create a new directory right here called concheck. So mkdir concheck. Okay. Now let's move the file we just downloaded from the downloads directory to the concheck directory we just created. So mv/home debian downloads concheck. Okay. To home Debian Python modules concheck. Okay, let's go to the concheck directory. So cd concheck ls. Okay, we can see the archive in this directory. Cool. Now, the first thing to do is to unzip this archive, and you can do this with the following command: tar zxf and the name of the archive. Okay, let's do an ls again. You can see that as a result of the unzipping process, you have a new folder here. Let's go into that folder. So cd concheck. Okay, ls. You can see a lot of files being in this folder. The file we are interested in is setup.py. Now I am assuming that you have distutils or setup tools already installed on your virtual machine if you are not using my virtual machine from my Google Drive. In case you are using it, then it is already installed. Setup tools is a Python package that allows you to quickly install any other modules. I'm not going to get into more details about setup tools. If you don't have setup tools on your operating system or virtual machine, Then I will attach a link to this lecture pointing to a website where you can download setup tools and where you can check the installation guide. Then after you complete the setup tools installation, you can come back here in this lecture and continue from this point on. Okay, so in our case, having setup tools already installed, we can use the following command to actually install this module. So Python setup.py install. Wait for a couple of seconds for the installation process to finish. Okay, the installation process is now completed. To check whether the module has been correctly installed on your operating system, just go into the Python interpreter shell and just import con check. If this will return an import error, then the module has been incorrectly installed, is corrupted, or is not on your operating system at all. If you don't get any errors and you just get the Python interpreter prompt again, then the module has been correctly installed and you can start using it. So import concheck. Okay, so in our case, the process has been successfully completed. This is how you install a Python module on a Linux operating system. Thank you. Okay, let me give you some advice on the way you should write your applications from what I've learned so far as a junior programmer. First, you'll see that in each application we will build, the topmost line in the .py file is going to be the following: a hash sign, an exclamation sign, /user /bin /env space and Python. This is called the shebang line in Python. This is a funny name. Most programmers use it, so we will use it too. Adding the shebang line means you can invoke the script directly by using a dot and a / followed by the script name into the Linux terminal, assuming, of course, you have the permissions to execute that file. I have attached a link in the additional section of this lecture to linuxcommand.org, where you can find more details on Linux file permissions. Now, let's create a Python file and see the difference between using and not using the shebang line. Let's go ahead and copy this. We will need it into our file. Okay. So let's say touch. Let's name our file shebang. Shebang.py. Let's go into the file. I for insert. Inside this file, let's type in the shebang line and then a simple print statement. Let's paste the line. Okay, and print testing. And a new line. Okay, let's save the file and run it. So Python shebang.py. Okay, it works. Now let's use the Linux way of executing files. This will be a dot, a / and shebang.py. And here's why we need to change the permissions. We can do this with the following Linux command: chmod 777 and shebang.py. Now let's try this one more time. Okay, this works too. You now have two ways to execute the same file. Now let's delete the shebang line and run the file both ways again. So let's get into the file. Let's go ahead and delete this and save the file. Now let's run it first in the old regular way using the Python command. Okay, it works. Nice. Now let's run it in the Linux way. So dot and a / shebang.py. Okay, this time we got an error. Linux didn't know how to execute the code inside shebang.py, so omitting this line just means Python has to be invoked manually with the Python command up here. Okay, enough about the shebang line. Let's go on to coding best practices. In the additional section of this lecture, you can find a link to PEP 8, which is the official style guide for Python code. In this guide, you will learn a lot of best practices for writing code in Python. But let me give you some basic best practices which I have learned while writing Python code. Let's go into the file from the previous lecture, thread.py, and let me add a few things first. So vim thread.py, okay, I for insert, okay, one more here, run the function 5 times, okay, let's see the file. Okay, as I said earlier in the course, one crucial thing to be careful about is indentation. You should always be consistent about your indentation. I would recommend using the tab key pressed once for one indentation level. I use this in my code and haven't had a problem until now. Another thing to keep in mind is that you should always write your import statements at the beginning of the file, before any other lines of code. Now maybe the biggest advantage of Python is the readability of the code. You should keep your code as readable and as clean as possible. For example, each time you create a variable and assign it a value, it's better to leave a space between the equal sign and the characters you type in on the left and on the right side of the equal sign. Another thing that might make your code more readable is leaving a blank line or multiple blank lines between functions, classes, or any other code blocks. You see I have a blank line here and another one over here. If you feel the need for any comments anywhere inside your code, use the hash sign for single line comments and, triple quotes for multi-line comments. They will help you 6 months later when you return to your code. Trust me on that. Also try to name your variables, functions, or classes as suggestive as you can, thinking about what that function does. For example, if you have a function that simply adds two numbers, you should better name it sum xy, for example, instead of just function1. Okay, I know this is a very basic example, but you got the point. I encourage you to read the entire list of best practices for coding in the link I told you about. Just keep in mind that keeping your code clean, readable, and compliant will help you a lot in your coding adventures. Starting with the next lecture, we are finally going to dive into networking using Python.